Good morning, everyone, and welcome to the third day of Marlog and its 13th iteration. We apologize for the delay. We were just waiting for the panelist. I should also point out that if you require interpretation, you can go ahead and visit this table over here. Today's first session is titled Sustainable Maritime Operations, Optimizing Performance Through Technology. This session is chaired by Professor Aziz Azzat. He's the President's Advisor of Education Affairs. He's also a Professor of Industrial and Management Engineering at the Arab Academy for Science, Technology, and Maritime Transport. Professor Azzat, you may take the floor.
Thank you very much for the presenting me. Good morning, everyone. I'm glad and honored to be here today with you, the third day of Marlog 13. This session theme is about sustainable maritime operations through optimizing performance with technology. We have 5 presenters today. Each presenter will have, with all my respect, 15 minutes to present his talk. And after finishing the 5 presentation, keynote speaker that we are delighted to have her, we will open discussion. So if you have any questions, please write it down, and we have about 10 to 15 minutes discussion after the session. So our first speaker and presenter, we are delighted to have Dr. Zhao Nan. She is the Deputy Secretary General of Shanghai International Shipping Institute. She has long been engaged in port researches, including regional port development, strategic planning, ports development studies, port management, shipping center, and other related studies. She hosted the annual compilation of global port development reports, which is, I guess, published quarterly and annually, developed the Service Efficiency Index of global major container ports using AIS, Big Data Academic. She also undertook more than 100 ports research projects, very impressive, and trusted by the government and enterprises. Many of her special reports have been approved by national leaders and provincial and ministerial leaders. Dr. Nan's presentation title is The Future of Ports, to be more efficient, smart, and resilient. So please, Dr. Nan, proceed to the stage. Thank you.
Thanks for the professor, and good morning, ladies and gentlemen. It's really a great honor for me to participate in the Marlog Forum. And thanks for the organizer to hosting the forum, bring us such rich information and ideas. Today, I want to talk about the future of ports to be more efficient, smart, and resilient. The topic will be analyzed from 4 aspects: port volume, port service, port resilience, and the relationship between port and the city. So let's look at the port volume first in the next 4 or 5 years. From 2020, we can see that the global logistics supply chain has suffered much more uncertainty. And the shipping industry always try to find the balance between demand and the supply chain and the supply. So especially the epidemic has a huge impact on global economy and the trade. And so that there were dramatic fluctuation in port production. The figure 1 shows that before 2011 to 2019, the average growth rate of global container throughput is 3.9%. If we calculate the throughput for 2022 to 2023 based on this average growth rate, there is already a large gap between the actual completion and the calculated volume. So according to the UNCTAD forecasting, average annual growth of 2.1% in global shipping transport over the period 2023 to 2027, which is lower than the average growth rate of 3.3% over the previous 3 decades. Also, Drewry forecast global container throughput growth of around about 2.7% from 2023 to 2027, also below the average growth rate of 3.9 over the past decade. So we can see during the next 4 or 5 years, low growth will be the big challenges for the port, and it will impact on the investment confidence in ports and further affect the supply of port infrastructure. But we also can see the chances. According to the decentralized layout of the global industry, in some special markets, there is also potential for growth. Now, let's look at about the port service. Talk about the importance of trend of port service efficiency. After the epidemic, the instability of the supply chain has made the industry chain more focused on safety and retaining redundancy. So the supply chain tends to become closer neighbors, and the intra-regional trade will be developed quickly. According to UNCTAD statistics, intra-regional trade accounts for about 50% in Asia and Europe. And the proportion of the regional shipping lines increased from 2005 to 2023. In 2023, it is about 43%, more than the proportion of east-west routes. Because of the regional trade volume increased, the ship size for it will be larger and the distance is shorter. So cargo owners engaged in intra-regional trade are much more sensitive to time efficiency than trade transport over long distance across oceans. And the time ships spend at port as a percentage of ships' operation time is increased, so that efficiency requirement for ports in the maritime logistic supply chain will be further improved, and the demand for just-in-time service will increase. The increase in the number of small and medium-sized ships serving ports has increased the efficiency requirements for tugboat, pilotage, and the berthing service at ports. The port efficiency mainly includes 3 aspects: port handling, port auxiliary service, and the port transport. Especially the port transport efficiency improve is very important and also very difficult, because it needs to cooperate with other transport modes. So here is a case. We can see in the picture 1 that Shanghai International Port Group has invested so many inland container terminals, which is located very near to the customers. And when the cargo owner send the cargoes to the ICT terminal, they can that seems the cargo already arrived at Shanghai port. SIPG will arrange the transportation for ICT to Shanghai port. The model makes connection and the arrangement between port and inland port more smoother. And with the development of e-commerce business, enable the combination of long-distance transport of large batches and faster distribution transport in close proximity. So there is a demand for integrated development between port and delivery, just like Costco has cooperated with Cainiao Express. When Costco shipped cargoes from Asia to Europe, and the Cainiao Express will deliver the cargoes from the Europe ports to the destination. The demand for personalized and customized port logistics service will increase. That means we should upgrading port functions from single node to full logistics supply chain. So there is a case for it. That is APM, AP Moller. AP Moller has purchased many logistic companies in order to provide best total logistics service for their customers. It purchased the customers' broker, Vandriff and KHG, and the warehousing and the distribution leader companies, Performance T. That makes APM acquire the more logistics and the customers' data. It also purchased the contract logistic company, just like Li Feng. That makes APM acquire more customer information and the logistic infrastructure. APM also purchased e-commerce logistic companies, air logistic companies, and the professional logistic companies. After the purchase, we can see APM's customers has expanded from 2B to 2C. The transport service expanded from shipping to air, road, and train. The service it can provide include transportation, warehouse, forwarder, and supply chain. The cargo she can provide logistic service from standard to specialized cargoes. Its network also expanded. But we can see another problem. The boundary between port companies, shipping companies, and the logistic companies has become blurred. Shipping companies have control over cargo source and international resources. But what port companies have? It's really a big challenge for the port companies. Thirdly, about the port resilience. As we know, input resilience of the port is to keep the capacity more abundance. But that also means efficiency of resources in use. So actually, we can improve the port resilience by cooperation and the digitalization transformation. Cooperation includes both vertical and horizontal dimensions. In the past few years, many port clusters has integrated in Europe and China. But after the integration, most ports still operate without a synergism. Vertical cooperation means collaboration between upstreams and downstreams of the industry chain. But vertical cooperation needs a synergy of data and information. There also is a case about the Singapore. So we can see Port of Singapore create a concept that's called GIT service. The earliest application of GIT is in manufacturing. It means zero inventories. Now it's applied in port industry. It means when ship arrive at port, they don't need waiting for the service. But all the service port provided should be coordinated under the digital spot. So we can see many ports start to improve the data exchange starts for port JIT system. And some ports began to strengthen the digital collaboration of port rail freight, such as Los Angeles, Long Beach, and Rotterdam. Last, I want to talk about the relationship between port and city. As we know, the development of the port makes the city more open and to attract more industry located at the cities. But now, in order to improve the efficiency of the port, so many ports combined together. Port development decision, strategy decision always made by the province instead of the city. That makes the relationship between port and the city less strong. So now we are stressing that port is one part of the city. The development of the city and the port should be consistent. Port city integration emphasizes the systematic and integrated consideration of port development and urban development in terms of spatial layout, functional positioning, development strategy, industry structure, policy support, and so on. It requires full integration of port and urban environment. Cities provide the bearing space and resource foundation for port development, and the ports provide strong guarantee and effective driving force for urban development. Thus, achieving port a continuous upward development model between industry and urban life. And furthermore, ports should be more greener and cleaner. That is the city living request. To be the green port, we should minimize the negative impact of the port area on the local environment and maximize the utilization of resources in port economic activities. In the past, we pay more attention upon the clean fuel utilization, ignore the resource utilization. Now, many ports has too many work on energy conservation and emission reduction, just like optimize the process, reducing effective operation, and also switching from using fuel to other clean energy. After the MEPC 80 meeting, decarbonization in shipping industry was accelerated. Ports should do more research and work provide clean energy. So far, there are 24 countries around the world have launched the 21 green shipping corridor construction initiatives, with port shipping companies and cargo owners participating. In future, port competitive position will be greatly affected by the green shipping corridor and the other decarbonization factors. So that is my view for the development of the future. Shanghai International Shipping Institute has published the Global Port Development Report for 14 years. This report tracks the latest development of global ports and provides a comprehensive analysis of the port on an annually and quarterly basis. Welcome to download this report on website. Thank you very much.
Thank you very much, Dr. Nan, for this visionary, strategic, very important topics you have handled. I wish this will be taken by many of us when we talk about supply chain disruptions, which is a very hot issue today, of course, and it affects too much the inflation and the balance between the gap between supply and demand. Thank you very much again. So please, may I draw your attention that if you have questions, let's postpone it to the end of this session. And I wish if you prepare your question written and handle it to the stage just to make an efficient discussion. Thank you very much. So our next speaker is Engineer Ahmed Abdullah. He is the Utilities and Energy Section Head, Veterinary Investment Group, Pharmaceuticals. Mr. Ahmed Abdullah worked as an MEP project engineer at Al Salam Consultants after his graduation in electromechanical engineering, Faculty of Engineering, Alexandria University. Now he is a candidate. He is applying or working on his research for MSc in the Arab Academy. His paper's title is Elevating Wind Energy Harvesting with J-shaped plates, a CFD-driven analysis of H. Darius vertical axis wind turbines. A very interesting topic. Let's hear Engineer Ahmed.
Hello, Mr.
Thank you.
Hello, ladies and gentlemen. Today we will talk about elevating wind energy harvesting with Jeep-shaped blades, a CFD-driven analysis of HDRS vertical axis wind turbine. There is one question before we begin. Why we don't see any wind turbines in any port, in any buildings, in any infrastructure, in sustainable infrastructure? Why we did as we wind and solar is the new trend, is the new energy. Why we didn't see any wind turbines? We will see the answer. Here is a comparison of the turbine performance versus tip speed ratio of the very different turbines. Here we see the most famous one, the three-blade rotor, the horizontal axis wind turbine. But this will not work in urban areas or in any buildings because of the low wind speed or the low tip speed ratio. So we have two only designs we can talk about in the urban area in the low wind speed, the Darius and the Vonius. Compared to horizontal axis wind turbines, these types of turbines are less efficient, especially the Darius, due to their low torque output in starting stages, because it make it unpopular and unfamous. Also characterized by unstable flow conditions inside rotor. But the effort has focused on small-scale devices for urban areas, for which low wind speed has a large impact on the turbine performance. So we have only two turbines where we can say that can be used in the low wind speed or in the urban, on the buildings. Due to their self-starting issues, we have only two criteria. If we can add electrical or mechanical mechanism to self-start, or we can change in the original design. So many design strategies have been investigated, such what if we can change the airfoil characteristics? There are so many designs. If we can say an angle to the design, concave in or concave out. What about we can increase the solidity of the turbine, increasing the number of blades or increasing the chord length of the turbines? What about if we can increase add an angle to the turbine to make it helical? What about changing the thin or thick airfoil? There are many design, but all of this has its advantage and its disadvantage. Many criteria we can use that have advantage and disadvantage. But if we show the G plate, which is the main topic here today, it's the Savonius and the Darius, giving the cup shape of the Darius, the Savonius, and the design of the Darius. Okay, so each one has its advantage and disadvantage. But if we see the disadvantage of the G plate with another perspective or another point of view, which is that has a lower performance at high tip speed ratio to high for drag because of the Savonius. But we will not go to the high tip speed ratio. We will not go to the high wind speed. We have low wind speed in the cities and the areas. So we will use as a 99% of the cases, we will not be the issue because we will be at low wind speed. G Blade after 2020 or 2019 has many investigation. It's a Darius and Savonius in one plate. And many researchers say that is encouraging topic. So other authors have different views. They claim that the G blade design don't provide any performance enhancement and don't recommend their use for Darius type vertical axle turbine. Further research was performed here that there are two main regions for the operating of the Darius: low wind speed and the high wind speed. High tip speed ratio and the low tip speed ratio. In the research which characterize doesn't recommend the G blade, doesn't recommend the G blade was at high tip speed ratio 5 to 6 and the low solidity. It's opposite to the which is encouraging researchers. So for high tip speed ratio, the wind flow is mainly attached to the airfoil due to the low angle of attack. However, when the tip speed ratio is in the low region, the angle of attack of the flow on the airfoil increase, leading to dynamic stall affect the high influence that the turbine performs. So in high solidity and low tip speed ratio is favorable for the G plate. Research objective. The previous researchers focused on blades with a hollow and a hair-like format, but didn't consider the internal geometry of the design. The present work evaluates the performance of the G blade with a field structure. This is the structure we are introducing in this paper. A 2D CFD model with NACA 0015 was created, and the results were compared to the experimental data from literature. This provides the base model. These are the characteristics of the wind turbine. 3 number of blades, standard number of blades, rated power 3.5 kilowatt, cord length and solidity, and 20 speed 10 meter per second. The validity of the model in this study has been examined in the comparison of the coefficient of power versus tip speed ratio curve, which was finding reported in previous studies. The CP is equal the CM times the tip speed ratio. Dynamic acceleration vector is the rate of a change of angular momentum. Is the angular from it. Dynamic acceleration vector is AKA is lamp vector. According to Darkuzi, the total external torque acting on a system of particles equals the rate of a change of the system total angular momentum. So if we understand and evaluate the chromic acceleration, we will be evaluating the torque. For a DD flow, the velocity is u in x direction and y direction, not in the z direction because it's a 2D flow. The vorticity is the curl of the velocity, as this. To extract the chromic acceleration is the cross product of velocity and vorticity. So to determine the chromic acceleration vector magnitude, we will be use this equation. This is the computational domain of our study, is a numerical study. The turbine is in the heart of the domain. You have two domains: the rotating domain, which the turbine rotate in, and the stationary domain. This is a great distribution of the mesh around the turbine. Many regions of refinement. Mesh get more fine as we go near the turbine. Structure and unstructured mesh refined near rotating turbine to get y plus less than 1, which is a requirement of the K omega SST turbine turbulence model. This is around turbine, more refinement mesh to get the result which is reliable on. This around turbine. Mesh independency study was being made to ensure that the CFD result doesn't depend on mesh density. We can get we made a more than 7 mesh study. Begin with about 300,000 cell till 2 million. The reference is a CB value reported by Tarkuzi is called in the blue line, and the CB obtained by the study is the orange. So we get when we get the similar with low computational cost about mesh number 5, we can get it. Numerical startup simulations assumption, K omega SST model, simple algorithms, utilizing second order upwind approach to get more reliable results. Azimuthal increment. The time step of the transitional simulation is the main, is one of the factors which is very important to get the transient. Azimuthal increment of at each time step is 0.5 degree, similar to numerical work of literature. Okay. Different tip speed ratio, 0.2 to 2.5. The number of revolution until conversions of simulated CB. When we get more high CB, we need more revolution to get conversions. Validation and verification. This is the CB comparison between the present study and the Tarkuzi. CFD-based study obtained from vertical axis were compared with result extracted from literature. A good match is obtained with a 1.8 average percentage of error. Now we can put G plate and get numerical result. Standard operating condition. The figures showed a better performance than NACA 0015 in most of the operation region. If you can see it in tip speed ratio 1.25, tip speed ratio 1.6. If we see that the G blade is the blue line and the NACA 0015 is the red line, we see that is more uniform, not high or low peak. But if we see in the tip speed ratio, high tip speed ratio, we will see that it's started to be lower than the NACA 0015 is the standard. If we see the velocity contours, if we can work, that's one.
Engineer Ahmed, will you wrap up your presentation, please? Because the time.
Okay. 2 minutes, please. If we see this in contours and velocity, we can see go to results. In the starting torque, the results is the average TM of NACA 0015 and the G blade. We get a 142% improvement in the starting torque. So we solve the problem of the self starting. Previous researchers used not a filled structure as a hair-like, but now we used a filled structure. We get about the conclusion is a better or equal performance in most of the operating regions. We increase the advantage of the self-starting. We can use vertical axis wind turbine in many urban areas and the cities. Thank you.
Thank you, Engineer Ahmed. This is a very hot topic again. It's very interesting. You open the gate for research in wind energy. And of course, the world and our country and the region is suffering from energy shortage. So the wind energy is, again, a very important issue. Of course, you open the gate, just open the gate for many, many research work in this area because the efficiency of the technology at its beginning stage. Thank you again. Our next paper and speaker should be by Professor Mustafa Hamad and his team from the Electrical and Control Engineering Department. Again, it's another important piece of technology dealing with a very important issue. The paper title is Recovery Braking in Electrical Boats using Dual Active Bridge DC-DC Converter with ultra capacitor. And it will be presented by Engineer Ahmed. He's one of the team of this paper. Thank you very much.
Good morning, all. Good morning, all. I will talk about the transformation of fuel boats into electrified ones by using ultra capacitor and dual active bridge. This is the outline of my presentation. First, I will talk about introduction, then proposed system overview, and then the role of dual active bridge in the proposed topology, and also the proposed control strategies and simulation results, and finally, I will end by the conclusion. First, electrified boats are gaining attention nowadays as sustainable alternative to traditional boats. Combining batteries with ultra capacitors can overcome challenges like limited power performance and also channels of fuel costs. Recovery braking in electrified boats converts mechanical energy into electric energy, making ultra capacitor ideal for hybrid application. So the proposed system overview consists of a recovery braking system for permanent magnet synchronous motor drivetrain in electrified boat by using bidirectional DC to DC converter, which is dual active bridge converter, to link ultra capacitor to a DC bus. Controller uses a BI or proportional integral controller assesses charging and discharging states for regulating terminal voltage. The system is modeled using MATLAB Simulink package software, comparing outcome against two control strategies. This is the architecture of our proposed system, that the thruster of the boats and also the inverter and lithium-ion battery pack and a secondary power supply, which is supercapacitor bank or ultra capacitor bank. And the proposed topology based on dual active bridge, which is DAB, to link the DC bus to the inverter. This is the construction of the dual active bridge. It consists of two full bridge and induction and the inductor and the linear transformer. It is a bidirectional power flow And as we see on the left, it is the supercapacitor or the ultracapacitor. We tested the system in two topologies, in the power flow charging mode and DC charging mode. As we see here, the DC charging mode, the power flow is going from left to right, from the battery pack and supercapacitor to the inverter and followed by the three-phase motor. And here is the charging mode of the ultracapacitor component. The controller is BI controller to control the PWM of the proposed dual active bridge converter. This is the Simulink system, ultracapacitor and the dual active bridge and the load and the pulse width modulation generation based on BI controller for the proposed system. This is a table of the specification of each component. The ultracapacitor selected was rated 80 farad, and the equivalent DC series is 8.93 milliohm, and the rated voltage is 400 volts. The parameters of the dual active bridge is turns ratio 2:1. The coupling inductance of the dual active bridge is 0.0102 millihenry, and the switching frequency of the DAB is 5 kilohertz. Also, the motor specification, torque 0.8 Newton meter, input voltage 300 voltage, and the rated speed is selected 3000 RPM. This is some of the simulation result of the driving behavior and motor speed and state of charge waveforms of the ultracapacitor during DC charging mode. The first curve is the driving cycle. As we see here, the driving behavior increase. It's the speed of the thruster, which has been evaluated in graph 2 as the RPM increase up to 3000 RPM. And also the SOC, the state of charge of the capacitor is decreased. Second scenario, while charging mode of the ultracapacitor or the supercapacitor, when the driving slow its speed or brake, and the speed tending to decrease, and also the SOC here can be charging. In hybrid mode of the driving cycle, we see that SOC can be changed, increased and decreased based on the driving cycle of the behavior of the driver. So, based on the dual active bridge technique, as we say, it is a bidirectional power flow. So the PWM in the charging mode are get to the first full wave bridge, and in the second case, the first was taken from the second wave bridge. So, based on this study, dual active bridge interface system are using for charging capacitor and DC charging ultracapacitor for the during regenerative braking system of the permanent magnet synchronous motor thruster. The system uses BI controller for efficient operation. Simulation results show the fast response and accurate performance of ultracapacitor. The research highlights the importance of advancement in energy saving in electrified boats and transform to electrified ones. So thank you.
Thank you, Engineer Ahmed, for presenting this very interesting piece of work. And let me tell you something. The Department of Electrical and Control Engineering in the College of Engineering and the Academy is very active in the research era. And the research field related to, as you see, DC converters and power electronics and electrical systems. This is very interesting, really. Our fourth speaker today is Dr. Captain Ahmed Magdi Abdel Wahid Khidr. He is the Associate Dean of Foreign Affairs and lecturer of Maritime Sciences and Hydrographic Surveying and Environmental Impact Assessment Consultant. So the title of the paper he's going to present today is the impact of differences between tides gauge and RTK tide data on dredging calculations in hydrographic survey. So please go ahead, Doctor.
Good morning, ladies and gentlemen. I'm Dr. Captain Ahmed Magdi Khadr. I will present today our paper titled The Impacts of Differences Between Tide Gauge and RTK Data on Dredging Calculations in Hydrographic Surveying Operations. Today, we will start we will talk about our outlines. We will give introduction and a case study on tidal data collected during hydrographic surveying operation, methodology in our research and results. And finally, we will talk about discussion and recommendations. Our connection to the conference today is the smart blue infrastructure. As an hydrographic surveying and hydrographic surveyor in the Egyptian Navy, we used a lot of information during our hydrographic surveying for the purpose of preparing new harbors under the title Smart Blue Infrastructure. The main topic for our operation, which is hydrographic surveying, is the dredging. Dredging, simply defined as removing sediments and wastes from the seabed. And it has two kinds of dredging: capital dredging and maintenance dredging. Capital dredging, we use it as initial step for initiating and development of a new harbor, while maintenance dredging is it's a maintenance done regularly in harbors and ports to maintain a depth in a certain area. Hydrographic surveying is a very essential operation. We start our dredging by doing a hydrographic surveying operation to determine the actual depths in a certain area. Hydrographic surveying, actually, we do it pre and post, before dredging and after dredging, to determine the volume of sediments excavated in a certain area. Hydrographic surveying is a very essential operation. It's done for many purposes, but one of the main purposes of hydrographic surveying is initiating and producing a nautical chart, which is very essential for mariners during sailing for safe navigation. And also for showing all mariners the reducted and the accurate depths in a certain area for the safety of navigation. So to determine an accurate depth in a certain area, we have to do dredging in the entrance of a harbor, for example. And after we do the dredging, we will get an accurate depth for the safety of navigation, so we can produce an accurate nautical chart. During our hydrographic surveying operation, we have to reduce the sea level fluctuations. Sea level fluctuations can be done by many factors, mainly by tide generating forces. It can be also as a result of meteorological effects, atmospheric pressure, wind speed, and wind direction. But now today we will talk about the effect of sea level fluctuation resulting from tide generating forces. So when the tide affects sea level in a certain area, we have to calculate the fluctuation of water, the rise of the water in that day to reduce the sea level fluctuation to a certain level, which is the short datum, to get an accurate depth in a certain area. To do this, we have to use an instrument to collect a sea level data. It is a very essential instrument, which is a tide gauge. We call it tide gauge, but actually it's a sea level gauge because it measures a time series of sea level fluctuation in the area of interest for long time. To get an accurate sea level fluctuations caused by tide generating forces, we need at least 18.6 solar year to get an accurate estimation of short datum in a certain area, which is very rare to find in urban areas or in areas where we cannot find a tide gauge installed. So we figured out for another solution to use another technique for collecting sea level fluctuation in the area of interest rather than tide gauge data. This actually is our problem, is estimating sea level fluctuation, which can be used to reduce the sea level from the depths calculated in the area of interest to get actual depths in a certain area. So now we are proposing using real-time kinematic tide data, which is collected from a GPS or a GNSS using satellite to refer sea level to a certain ellipsoidal height. Ellipsoidal height is the mathematical model which represents the area of interest. So we can depend on the RTK data rather than tide gauge data, which needs at least, as I said, 18.6 solar year of data. So our aim today is to compare between calculating volume for the dredging purposes using a tide gauge data and using RTK data in the same area. Our case study was during our operation of hydrographic surveying and dredging in Suez Canal between the kilo point 122 to kilo point 132. So we collected data for hydrographic surveying operation as a pre-calculations for the depths before doing the dredging in the Suez Canal. We used many equipments during our surveying operation. We used a reference point on the shore. We used multi-beam EchoSounder T20. We used POSE MV for position, heading, motion sensor, and we use tide data and also tide RTK, real-time kinematic tide data from GPS. Here we have the multi-beam data collected in the area of interest using all the equipment mentioned, and all the equipment mentioned was integrated using the software PDS, Teledyne. We processed all the multi-beam data collected in the area. Then we calculated the difference in hydrographic surveying between using tide gauge data thus using real-time kinematic data. As we can see here from the figure on the left, a comparison between using RTK data and tide gauge data in a distance 1 kilometer from the base station, from the shore, which is very near to the tide gauge and very near to the base station. Now, on the right, we used the same data, same equipment, same area, but away from the shore and away from the base station by 10 kilometers to show the difference between using data of tide gauge against using data of RTK in volume calculations for the purpose of in hydrographic surveying for the purpose of dredging. Here we have the differences between using a tide gauge 1 kilometers away from shore and using tide gauge and RTK away 10 kilometers from shore. From the table on the left, we can see that the average difference in volume between RTK and tide gauge is plus or minus 3 centimeters. While when we are away 10 kilometers, the average difference in volume between RTK and tide gauge plus or minus 15 centimeters. As we can see here, that the data from the figure here, about 1,473 cubic meter, shown here as the green area, which is the difference between the data collected using tide gauge and RTK 1 kilometers away from the shore. And the error in the data is from 0 to 10 centimeters. But here in this figure, we can see away from the shore, 10 kilometers, the difference between the RTK and tide gauge in volume, about 36,991 cubic meters, which is a very huge amount of sediment, and it will cost a lot, and also it will take a lot of time. And if we consider this a place of interest to exaggerate and remove sediments from this area, we will have an error about 36,991 cubic meter. So from this, in our area, dimensioned 1,000 meters in length and 300 meters in width, 300,000 square meters area, 1 meter away from shore, 1 kilometers away from shore. The error in volume, about 9,000 cubic meters, which is a permissible error in volume calculations for dredging operation. On the other side, comparing the same dimension, an area with 300,000 square meters, the volume error, 10 kilometers away from shore, with error 15 centimeters, the volume error will be 45,000 cubic meters, which is a huge amount between using RTK tide and tide gauge. So the conclusion is the tide gauge data for hydrographic surveying for the purpose of dredging in a certain area is very accurate tool for reducing sea level to get an accurate depth. While using RTK in shore area, close from the shore, 1 kilometers away from shore, not that far, the difference will be 9,000 cubic meter. When we go away for 10 kilometers, we will see that the difference between data collected using tide gauge and data collected using RTK will be almost 4 times the error near shore. So we recommend that we use tide gauge data for hydrographic surveying operation during dredging rather than using RTK data. And it should be limited for a certain area and not away from shore. We will try to investigate later on using a regional model to represent the chart datum in a certain area using a tide gauge from nearby stations. Thank you. And any questions?
Thank you, Dr. Khadr, for this impressive presentation. As I said at the beginning, we will postpone the discussion after the end of the session. So if you don't mind, would you please join us? Because I believe this impressive piece of work will open a lot of discussion. The beauty about this presentation is it's completely experimental. Which is something the people of the domain knows quite well, that this is something which is not easy to be established and to get a real conclusion about it. So again, thank you very much. Our fifth speaker is engineer Michael Shafi. Engineer Michael Shafi is a TA at the Arab Academy of Science and Technology. He is graduated from the Marine Engineering Department and the Academy. His master degree in Maritime Engineering investigated the residual stresses using acoustic emission technique, and he published some of his results. Now he is working on his PhD thesis, and he investigated the vortex induced vibration. Again, very interesting topic on a marine riser. Engineer Michael's paper title is Numerical Analysis of Enhancing Water Drop Bearing Design to Mitigate Vortex Induced Vibrations by Applying Angular Slot. So, go ahead.
Thank you, Dr. Izzat. I'm very happy to be here with you in this great conference, and I'm very grateful for my supervisors and especially Dr. Ahmed Samir, who helped me so much for in my research, and he is always helping me whenever I need it. Thank you so much. First of all, I'm talking about the numerical analysis for vortex-induced vibration applied on a tube, and we actually using a fairing in the presentation here. It will be divided into 4 parts. The first part is about introduction, and then the methodology, and the results and discussions, and finally the conclusion. First of all, the introduction. The introduction is divided into 2 parts. I will give you just a brief view about the problem and the way to solve it according to our point of view, which is the marine fairing. First of all, the marine riser are critical components of offshore oil and gas production system that connect the bottom to the surface of the platform. They are subjected to vortex-induced vibration, and as a result, marine risers are subjected to collapse, which can have catastrophic consequences such as environmental damage and loss of output and even death. Actually, if you look in the picture on the left-hand side, that this long tube is the marine riser that we are talking about. So there are many methods to reduce the vortex-induced vibration, but today my research is about the fairing. And there are also different type of fairings, but my paper is about the special part, which is water drop fairing. And I used the angle theta, 80 degree. Actually, this is a good design for a fairing, but the problem is that it needs more optimization, and that's what I'm working about today, because its drag, its coefficient of drag is higher than much smaller angles. But it has an advantage because it's smaller. It's much smaller than other angles, because if you use a fairing with an angle much smaller than this, it will be so long. So this is not practical. So let's talk about the methodology. We have 2 parts in the methodology: the concept and the software setup. First of all, the concept. Actually, I'm building this paper on another paper that I found that at the distance 0.13 D from the tail of the fairing, this was the best point for the drag coefficient and vortex-induced vibration. So I used something new in this part. I used an angle, slotted angle, okay? And the angle is either measured counterclockwise or clockwise. Clockwise, I used a symbol as the beta CW for clockwise, and counterclockwise is beta CCW. The angle is increased from 0 to 40 in both directions, with a step size of 5. So the angle will be 5, 10, 15, up to 40 in both directions. The key for using for determining which angle is the best, I used the root mean square for the lift coefficient, which symbol is CLRMS. The angle between the slot, the angle is altered in both sides, as you see. I took the red for counterclockwise and green for the clockwise. Okay, the software setup. I used simulations on ANSYS Fluent. The device was i7 12th generation. It's such a recent device, okay? And I put the highest possible number of elements that this device can achieve. And of course, I compared my results to literatures, but the comparison was in my previous papers. So I got 0.8 or 0.9 elements, million elements, which the element size was 0.02 millimeter. That is the smallest size for the element. Oh, so if we look at the domain, the upstream was 5D and the downstream 30D. In and out flow widths 10D. I took D as 1 meter, and the velocity for the fluid, of course, water, 1 meter per second, which equivalent to Reynolds 10 power 6. I just make my results on velocity 1 meter per second, which is equivalent to Reynolds 10 power 6. And the boundary conditions was for inlet velocity inlet, outlet, pressure outlet, wall was symmetry, and the fairing, we take it as non-slip. For result and discussion, okay, let's remind you, I took the green for the clockwise and red for the counterclockwise. So if I will not talk about all this data, but what I'm looking for is the smallest value for CL RMS. So I found that at angle 30 degree, I got a decrease by about 38%. And this is such a great value. And also at 5 degree, what's a good result, but not the best for the clockwise. And for counterclockwise, I found that at angle 15, the decrease was only 9%, about 9%. Here we can look at the velocity streamline. The visualization reveals that the flow boundary layer deattaches layer for angle slot fairing in comparison to the vertical slot. Here we are talking about the angle 5 and 15 and 30. Some of them are clockwise and other counterclockwise. The delayed separation observed suggests enhanced flow adherence and decreased pressure fluctuation, resulting in reduced vortex-induced vibration amplitude. The comparison here shows that the pressure contours demonstrate a noticeable change in the wake area when using angle slot fairing, as opposite to vertical slot. Vertical slot is the one on the top, and the other angles 5 and 15 and 30, the three good ones, and of course one of them was the best, which is 30. Demonstrate a noticeable change in wake area when using angle slot fairing opposite to vertical slot. The observed change suggests a disturbance in regular pattern of vortex shedding, which result in a decrease in vortex-induced vibration, as anticipated by the flow models. And finally, the turbulence kinetic energy. The turbulent kinetic energy here show lower overall, lower level of TKE, or turbulent kinetic energy, compared to the vertical slot, the one on the top. Okay. Signifying a decrease on the overall energy associated with the turbulence fluctuation. This suggests a calmer flow regime and potential reduced energy transfer to a cylinder, leading to lower vortex-induced vibration response. So the conclusion: the fairing with the angle beta equal to 30 clockwise with the vertical has proved to be the best in damping vortex-induced vibration. As a result, it shows the lowest value of CLRMS. Also, we have two other angles which are good, the 15 and 5. Both of them show 9 and 6 decrease in CLRMS by 9 and 6 compared to the vertical one, which we take it as the datum. Okay. Thank you so much.
Thank you, Engineer Michael, for this very impressive paper, piece of work. Of course, the topic related to vibration and specifically self-excited or self-induced vibration is not something new. It's a classical, traditional piece of science. However, the new techniques for analysis and experimenting with this traditional approach, this is again the most interesting part of this paper. I wish this will open discussion among the audience here. We have finished our presenting our 5 speakers. Now is the time to open discussion. If you have questions, and as I said at the beginning, if you have questions, please write it down. State the name of the speaker you want to address the question to him. So if you have questions, or at least just mention your name and the name of the speaker if you have questions. Thank you. We have only 10 minutes or something before we wrap up this session. Please.
My name is Hisham Safti. I'm from DHI. I have a question to Mr. Michael, who presented the last presentation. So, did you consider doing any mesh sensitivity? Because how can you be sure that the mesh is valid for your calculations? The second question.
Will you please, excuse me, will you please raise your voice because we couldn't hear you?
I'm sorry, is this better? Okay. I have like very small questions, so I will just take them one by one. First, did you do a mesh sensitivity? Mesh sensitivity analysis.
Actually, I compared my result to another experimental data. So I'm sure it's okay. I didn't change the velocity. I used the same velocity for the experimental data. Reynolds number 10 power 6. So that's why I don't need to, and I get such close enough to the experimental.
Okay. But
I compared it to actually it's fluid dynamics book. It's called the author I think is called White. It's White. It's so common or so known book in fluid dynamics.
And which turbulence model did you use?
What?
Which turbulence model did you use?
Yes, I forgot to mention this SSTK omega.
Okay. And how did you treat the boundary layer?
How?
The boundary layer. How did you treat that at the horizon?
How I choose it?
How did you treat the boundary layers?
Sorry, I don't get it.
The boundary.
Yes.
How did you treat the boundary? Y plus.
Yeah. I talked about the boundary conditions. You mean?
Okay, no problem.
What are you talking about? The boundary
I'm talking about the boundary at the riser. Did you do any boundary elements just to, or like?
No.
When you function, something like that.
No, I don't get it. Actually, I don't get what you are talking about.
Last question. Do you think if you consider fluid structure interaction, will your results be different?
What? Sorry?
You have your riser as fixed in space, right? Doesn't
Yes.
move. If you consider fluid structure interaction, does that change the results much?
Moving, you mean moving? Of course, it will be different. But here I'm talking about a fixed one, a fixed riser, not a moving. Actually, there are some fixed and some are moving. So I'm talking about I'm making experiment about a fixed one.
Okay, but if you included the motion in your investigations, do you think this will change the results?
Maybe, I'm not sure.
Okay, thank you.
We have to investigate this.
Thank you very much.
Okay.
Okay. Any further questions? Okay. Thank you very much for you and all of you colleagues and friends. And let's finish up this session. Thank you very much to the speakers. And now we have a ceremony for presenting some gifts to you. Thank you very much. See you again.
And now, Professor Ismail Abdul Ghaffar Ismail Farag would like to give an award to the panelists. Yes. نعم. بدك تحبه. مش مشكلة. شرفني يعني. لا والله. Receiving on behalf of Dr. Chao Nan, Professor Chen Wen Yu. Engineer Ahmad Abdallah. Receiving on behalf of Professor Mustafa Hamid, Engineer Ibrahim Gaber. Receiving on behalf of Mr. Ahmad Gharib, Dr. Ahmad Magdi. Engineer Michel Adel Shafi. Could the panelists join us for a group photo? We just want to dedicate special thanks and gratitude to Dr. Michael for his attendance and contribution with us today. Okay. Thank you very much, everyone, for attending with us the first session. We are on time, so the second session will start at 11. So please be there on time. Thank you very much.
بالإسكندرية، أحد متاحف مصر الكبرى والوحيد في مصر المتخصص في آثار وحضارة مصر في العصرين اليوناني والروماني. منذ عام 1889 سعى الإيطالي جوزيبي بوتي إلى تأسيس متحف للإسكندرية كي يحمي آثارها من التهجير والتدمير، وظل يعمل على ذلك إلى أن أنشئ المتحف وافتتح في 1 يونيو 1892. المبنى الحالي فهو أقدم مبنى في مصر يصمم معمارياً كمتحف، وافتتح في 26 سبتمبر 1895. في سبتمبر 2005 صدر قرار بإغلاق المتحف لإجراء مشروع شامل لتوسعة وتطوير المتحف. وضع تصميم جديد بإضافة طابق علوي، ونفذت صياغة جديدة للعرض المتحفي موزعة على 27 قاعة وفق موضوعات محددة تبرز جوانب حضارة مصر في العصرين اليوناني والروماني حتى 641 ميلادية. الإسكندر المؤسس. في خريف عام 332 قبل الميلاد تقدم الإسكندر الأكبر إلى مصر وانتصر على الحامية الفارسية دون قتال، واستقبله المصريون كمحرر. في طريقه لزيارة معبد آمون بسيوة اختار الإسكندر الأكبر موقع قرية الصيادين المصريين راكودا لتأسيس العاصمة الجديدة الإسكندرية. الحكم البطلمي. أعلن بطلميوس بن لاجوس نفسه ملكاً على مصر 305-306 قبل الميلاد، واستكمل بناء العاصمة. خلفه 14 ملكاً جميعهم حملوا اسم بطلميوس وصولاً إلى تلك الشهيرة الطموحة كليوباترا السابعة. الحياة اليومية في العصر البطلمي. التناجرا. ترجع مجموعة الإسكندرية من التماثيل الطينية الملونة المعروفة باسم التناجرا في معظمها إلى القرنين الرابع والثالث قبل الميلاد، تصور نساء وبنات وأولادا من المجتمع السكندري. الساقية. كان هذا الرسم الجداري يزخرف جدران مقبرة بمنطقة الورديان بالجبانة الغربية للإسكندرية، يصور الموضوع منظراً للساقية التي تعكس البيئة الريفية المصرية بواقعية. الحكم الروماني. استولى أوكتافيون على مصر بعد هزيمة ماركوس أنطونيوس في أكتيوم ومرسى مطروح في 31 قبل الميلاد، حيث صارت مصر ولاية تتبع الإمبراطور شخصياً ولا يدخلها القناصل إلا بإذنه. الحياة اليومية في العصر الروماني. المنزل الروماني. هنا محاكاة لمنزل روماني أعيد تكوينه بمواد حديثة. يتكون المنزل من غرفة المآدب زينت أرضياتها بلوحتين من الفسيفساء. في الخلفية تظهر محاكاة لمكتبة خاصة يحاكي الجزء التالي مطبخاً وحماماً من العصر الروماني. الرأس السوداء. هذه مجموعة من التماثيل الرخامية المنفذة بمذاق فني راقي ترجع للعصر الروماني، اكتشفت بجوار معبد الرأس السوداء، المعبد الوحيد المكتشف في الإسكندرية في حالة جيدة. الحياة العلمية. الأرجح أن بطلميوس الأول هو من بدأ مشروع إنشاء الموسيون والمكتبة. ساهم الموسيون ومكتبته الكبرى بدور كبير في الحياة العلمية والأدبية في الإسكندرية والعالم الهلينستي، حيث نقابل كثيرا من أفراد صفوة العاصمة والأقاليم في البرديات وفي النقوش يربطون أنفسهم بالموسيون، وكانوا يظهرون في حياتهم اليومية بهيئة المتفلسفين والمتعلمين ذوي الثقافة اليونانية. الحياة بعد الموت. شهدت مصر امتزاجاً نادراً بين 3 حضارات هي الأعظم في تاريخ البشرية، تمثل بجلاء في المعتقدات الجنائزية وخلف نتاجاً حضارياً فريداً من نوعه، حيث دفنت الأدوات والمنقولات مع الموتى الأثاث الجنائزي في العصرين اليوناني والروماني كي تشهد استمرارية وتغيير في الوقت نفسه، فكان من أهمها صور المومياوات، الأقنعة، بعض اللفائف، اللوحات الجنائزية، الأواني الكانوبية، التوابيت والعملات. النيل. كانت الإسكندرية تشرب ماء النيل الذي كان يأتيها عن طريق اتصال بحيرة مريوط الواقعة جنوب المدينة بالفرع الجنوبي للنيل. جسد المصريون القدماء النيل بهيئة رجل ممتلئ البطن والأثداء رمزاً للخصوبة، وفي إطار الرؤية اليونانية لتشخيص الأنهار في وضع الاتجاع، فإن النيل أيضاً تم تشخيصه في العصرين البطلمي والروماني مضطجعاً. التجارة. تعرف الإغريق على الطرف الشرقي خلال الحروب الفارسية فأصبح مصدراً لسلع أساسية في العبادات اليونانية، ومن أهمها البخور. كانت السيطرة اليونانية على مصر نقطة تحول في التجارة الشرقية. أنشئت مواني مثل برنيكي، مرسى علم، وميوس هرموس، أبو شعر القبلي، وأرسينوي، السويس. كان أول ما انتشل من تلك الآثار عام 1968 هذا التمثال الضخم بجزئيه، واعتقد أنه يصور الإلهة إيزيس فاريا، وهي صفة تنسب إيزيس إلى جزيرة فاروس. لكننا أصبحنا الآن نعرف أنها ملكة بطلمية قد تشبهت بإيزيس. المتحف اليوناني الروماني بالإسكندرية أحد متاحف مصر الكبرى، والوحيد في مصر المتخصص في آثار وحضارة مصر في العصرين اليوناني والروماني. منذ عام 1889 سعى الإيطالي جوزيبي بوتي إلى تأسيس متحف للإسكندرية كي يحمي آثارها من التهجير والتدمير، وظل يعمل على ذلك إلى أن أنشئ المتحف وافتتح في 1 يونيو 1892. المبنى الحالي فهو أقدم مبنى في مصر يصمم معمارياً كمتحف، وافتتح في 26 سبتمبر 1895. في سبتمبر 2005 صدر قرار بإغلاق المتحف لإجراء مشروع شامل لتوسعة وتطوير المتحف. وضع تصميم جديد بإضافة طابق علوي، ونفذت صياغة جديدة للعرض المتحفي موزعة على 27 قاعة وفق موضوعات محددة تبرز جوانب حضارة مصر في العصرين اليوناني والروماني حتى 641 ميلادياً. الإسكندر المؤسس. في خريف عام 332 قبل الميلاد تقدم الإسكندر الأكبر إلى مصر وانتصر على الحامية الفارسية دون قتال، واستقبله المصريون كمحرر. في طريقه لزيارة معبد آمون بسيوة اختار الإسكندر الأكبر موقع قرية الصيادين المصريين راكودا لتأسيس العاصمة الجديدة الإسكندرية. الحكم البطلمي. أعلن بطلميوس بن لاجوس نفسه ملكاً على مصر 305-306 قبل الميلاد، واستكمل بناء العاصمة. خلفه 14 ملكاً جميعهم حملوا اسم بطلميوس وصولاً إلى تلك الشهيرة الطموحة كليوباترا السابعة. الحياة اليومية في العصر البطلمي التناجرا. ترجع مجموعة الإسكندرية من التماثيل الطينية الملونة المعروفة باسم التناجرا في معظمها إلى القرنين الرابع والثالث قبل الميلاد، تصور نساء وبنات وأولادا من المجتمع السكندري. الساقية. كان هذا الرسم الجداري يزخرف جدران مقبرة بمنطقة الورديان بالجبانة
Could the panelists join me on stage, please? Find your chair like in the middle.
Okay.
Welcome back. We will now hold our second session titled Sustainable Logistics, Leveraging Innovation to Improve Quality, Efficiency, and Environmental Impact. The session is chaired by Dr. Zhong Yang. He is the Associate Head of the Department of Logistics and Maritime Studies, the Hong Kong Polytechnic University, Hong Kong, SAR, China.
Okay, so ladies and gentlemen, welcome to this session. I'm very pleased to be here to introduce our five very reputable and distinguished speakers. So today we will have five presentations, and the first one will be presented by Professor Li Xingsheng from Dalian Maritime University. And her topic is stability analysis of maritime logistics alliance based on blockchain. So now I would like to give the floor to Professor Shen, and Professor Shen, please. Thank you. Yeah.
Thank you for Professor Yang. Distinguished Professor Oxama, and ladies and gentlemen, good morning. I come from Dalian Maritime University of China. My topic is stability analysis of maritime logistics alliance based on blockchain. I prepare a quite very short introduction about DMU, Dali Maritime University, and myself. But according to the time limitation, I just give a quick, let's a quick see. This is Dalian, a post city. And I come from Dali Maritime University. Dali Maritime University is a Project 211 and the double first class university plan in China. And his history can trace the 1909. We have about 1,600 full-time staffs and about over 20,000 students. This is the campus of our university in different seasons and some full function teaching facilities. This is our library. Okay, we have 3 ocean-going training vessels. Okay, let's come back to my topic. My research field is focus on intermodal transportation and the supply chain sustainability and blockchain. My topic is stability analysis of maritime logistics alliance based on blockchain. I will report as follows logic. Firstly, the first part is research background. The second part is introduction of literature review. The third part is affecting factors analysis for the stability of maritime logistics alliance based on blockchain. The first part is modeling of benefits distribution in maritime logistics alliance. The fifth is designing of benefits distribution smart contract. The last part is conclusion and limitations. Okay, let's come to the first part, background introduction. As we all know, more than 19% of world's free transportation is completed by sea transportation. However, there are many challenges in maritime logistics field, such as the lack of timely access to logistics information, obstacle to environmental adaptation, and the difficulties in resource integration. In order to realize the goal of higher efficiency and a high benefit than engaged in maritime logistics business alone. Maritime logistics enterprises, domestic logistics enterprises, and overseas logistics enterprises of the relevant parties to form resourcing sharing, mutual benefit, and win-win situation complementary advantages, risk sharing logistics partnership, also known as Maritime Logistics Alliance, MLA. However, the stability of MLA has always been the key problem that affects the continuous operations of the alliance. Subject to the cross-border and the cross-regional constraints and the respective repetitive and complex workflow and inconsistency in standards and the lack of trust and the different difficulties in sharing information. The last one and is the important one, satisfaction of the benefits distribution can't meet the requirements of MLA. So blockchain that, as we all know, blockchain technology is characterized by opening, decentralization, openness, and transparency and traceability may greatly improve the stability of maritime logistics alliance. The second part is the introduction of literature review. I just gave the summary of the literature review. Firstly, blockchain can greatly improve the stability of maritime logistics alliance, but fewer research on maritime logistics based on the blockchain. Secondly, the application of blockchain technology makes the benefit distribution mode of the alliance change, and the change of the benefit distribution mode seriously affect the stability of the maritime logistics alliance. So we can find the research gap. How to realize the benefit distribution of MLA based on blockchain is the key to improve the stability of maritime logistics alliance. We get our research content according to the research gap. First is affecting factors analysis for the stability of MLA based on blockchain. The second is modeling of benefits distribution in maritime logistics alliance. The third one is smart contract design for benefit distribution of MLA. Let's come to the first part, affecting factors analysis for the stability of MLA based on blockchain. Firstly, we gave analysis of the workflow and the information sharing mode of maritime logistics alliance based on blockchain. Then we gave stability analysis of maritime logistics alliance based on three-party game theory. Okay, we can see the first picture show the traditional maritime logistics alliance workflow and the information sharing mode. We can see the disadvantage, isolation of modes, duplication of workflows, inefficient transfer of information between nodes. Then we establish the new mode for workflow and the information sharing of logistics or maritime logistics alliance based on blockchain. We can see from the picture all nodes form an alliance, and the information only needs to be uploaded once to simplify the workflow. Okay, through the literature analysis, the following four factors affect stability of MLA in the context of blockchain. The first is the level of information sharing standards. The second is the reasonable distribution of benefits within alliance. The third one is the cost of technological inputs. And the last one is the cost of risk. Okay, now let's go to do the three-part evolutionary game theory in these papers. In this research is adapted to explore which factor has the greatest impact on the stability of MLA. We do these works as follows. First, the model assumption. The second, the revenue matrix construction. The third one is revenue expectation function construction. The fourth is game theory evaluation path analysis. The fifth is game stability strategy analysis. The last one, simulation analysis. This is the first model assumption, and the second revenue matrix construction. This is the third part, revenue expectation function construction, and the fourth one, and the fifth. This is the last part, simulation analysis. we can find the many results according to the analysis. Maybe I have no time to show it one by one. Later, we can discuss later after the session. Okay. Altogether, through the above simulation analysis, it is found that the regional benefits distribution factor coverage fasted, which shows that the factor has the greatest influence in the stability of alliance. Oh, okay. Next part is the modeling of benefits distribution in MLA. Yes, we do two parts works. The first is the benefit distribution model based on the modified Shapley AHP. The second part is AHP-based weighting analysis of factors of interest and influence. Okay, I'm not sure how many minutes have passed, so I just show our result. Okay, the fifth part is designing of the benefits, construction of smart contract. Okay, smart contract. Why we do smart contract design? Because the smart contract is the smallest program unit running in the blockchain platform. So we have to design the smart contract and to realize to our purpose. The benefit distribution of the information sharing model based on blockchain can be realized by the smart contract, which can automatically execute the benefit distribution mode and record the result on blockchain to ensure that the distribution of benefit is transparent and fair. Meanwhile, the automatic execution of smart contract can also reduce human interaction, thus improve the security and the ability of the system to ensure that all members get a fair return. Okay, we combine smart contract and the deployment and the calling to the calling. That's the procedure we programming that. Okay, the last part is conclusions and limitations. In this paper, in this research work, firstly, we analyze the stability of the maritime logistics alliance based on blockchain and obtains a reasonable benefit distribution is the most important factor which affect the stability of the alliance. Then a modified Shapley AHP model is constructed to obtain the benefit distribution coefficient of each member of the Maritime Logistics Alliance. And a smart contract for benefit distribution is designed to make the benefit distribution ultimate, ensure fairness and transparency in distribution of benefits. Okay, they are as follows, the specific content. The limitation of this research is the feasibility of the mode needs further validation. As we all know, the application of blockchain technology is in this field is still in the early stage. So the feasibility of this mode has not been actual operation and verification. Okay, that's the end. Thank you very much. Can I go?
Okay, thank you, Professor Shen. And I know the blockchain is a hot topic a few years ago, since a few years ago in the maritime industry. And I also know some shipping company and the port try to put this into practice. use the blockchain to solve the practical problem. But honestly, so far, I don't see any real product of blockchain. Maybe there's some, but not in my knowledge. So this is quite a good topic, and I really hope to see some real like a blockchain platform can be implemented in the near future. And because we have 5 speakers, so my idea is after finish all the presentation, we will leave the discussion time for Q&A, okay? So our second presenter is Dr. Enrico De Agostini. And he's a senior lecturer in the logistics from the Department of Business and Enterprise Management University in Malta. So now I would like to invite Dr. Enrico De Agostini. Sorry, my pronunciation may not be right, but welcome and please. Yeah.
Thank you very much, Mr. Chairman. Ladies and gentlemen, good morning. My name is Enrico D'Agostini, and I come from the University of Malta. Just before kicking off, let me express my gratitude to Dr. Sarah El-Ghazar in particular, to Dr. Sandra Haddad and Dr. Amira Mandu. They work very hard and they made our experience a very positive one here at Marlog. So as many other presenters, I've used the picture where I look younger. And my topic for today is going to be logistics cooperation in the Far East, prioritizing supply chain requirements to strengthen inter-regional integration of maritime transport network. You might wonder why I focus on the Far East region. I lived in South Korea since not long ago. So I focus on that area, although I'm based in Malta. Just a very brief background. We know that it's long been established that efficient logistic process and supply chain network are being long considered driver for competitiveness and economic growth, not only for private organizations and firms, as well as for governments. The successful implementation of policies related to logistics, supply chain, and transportation can lead to growth and enhanced logistics performance. Nevertheless, when it comes to regional governmental cooperation, there is some topics which appears to be more important than others. A few of them are namely technological changes, data interchange, and sustainability or greening of supply chains, and all be considered important ones. The data for this study have been collected during 2020, which was an important time. As we know, the impact of COVID-19 pandemic outbreak has heavily disrupted supply chain and maritime network in particular. So the rationale for this study, we've started looking at past joint statement issued every 2 years by the government of China, the Republic of Korea, and Japan. So the 3 governments produce documents where they discuss the analyzed area of logistics cooperation for the Far East region. That was our starting point. So we aim to understand what areas, what priorities have been discussed by these 3 governments. So this is the first study from the author perspective knowledge to try to provide some ad hoc policies with regard to regional cooperation in the Far East. So what we did here basically is sort of 3-step research method. In the first step, we apply a text mining method. So we looked at past joint documents issued by Korea, China, and Japan, and we text mine the most important logistics terms. In the second step, we used a slightly different approach, a Q method, which is a mix of qualitative and quantitative analysis, where we ask some respondents, what are, in your opinion, the priorities which should be discussed from a regional perspective? So we compare basically what has been discussed in the past and what should be prioritized according to the subjectivity of some of the respondents. In the third step, we try to provide some policy recommendations based on step number 1 and step number 2. So the research question here, very briefly, Number one, what are the most important logistics area of cooperation of China, the Republic of Korea, and Japan, based on past joint ministerial resolution? Number two, we want to know, compared to the past, what are new logistics priorities which should be properly addressed and discussed to enhance and improve cooperation between China, the Republic of Korea, and Japan? Third, the policy recommendation on new logistics trends. So in the first step, we apply a text mining methodology. We use a NetMiner software, and we collected 8 full documents from 2006 to 2020. So 2020 in reality has been our sort of baseline prior to 2020. We extracted a total of 2,556 words, which range from a frequency of 594 to 1. Obviously, we focused on purely logistics terms. Therefore, we deleted those that were non-logistics related. So the results, in the analysis, we also obtain a degree centrality, which provides an important of these terms extracted within a network. And we also analyze the community betweenness to draw a sort of hierarchical structure from the text mining. So overall, we were able to sort of cluster the most important area of cooperation between Korea, Japan, and China. The first one, as you see, cluster number 1, included words such as greenhouse gas emission, market transportation. So this is a strong indication that environmental issues have been discussed in the past. Number 2, policy, research, sharing information, port cooperation. So again, data sharing, a bit more on technology issue here. Number 3, again, technology, research, sharing information in a more general way. The previous one was more about ports. The fourth one is about standardization, regulation, safety, network, and system. Number 5, Asian. So here is also an indication that the 3 governments in the Far East, from a logistics perspective, are looking as well at Southeast Asian nations. Transport, intermodal, and port. And the 6th one is about energy, efficiency, cost chain, transport, and equipment. The second implication that is derived by the first step is that China, Republic of Korea, and Japan are, as nation, are central to the transport value chain in Asian countries. So the impact of transportation issue in the Far East really extend beyond the region itself. And there has been quite a few areas of discussion extracted from the first step. The second step, which again, the subjectivity of respondent was taken into account, was done via a Q methodology. As you can see, the Q methodology evaluate the subjectivities and the viewpoints of respondents, and has been quite widely used in social science. It involves a 6 steps process. We followed quite strictly this process. As you can see, from number 1, there is a sort of literature review search where we have really an extended search of what could be the terms, the areas of logistics cooperation. In the second step, there is the production of the Q set with a selection of 35 Q statements. And in this case, we also had the help of 3 experts in the field. The third step is the P sample, which is very important, and has been the selection of 31 participants. I must tell you that the participants were all coming from the Republic of Korea. So this research, one of the limitations is that the research is biased purely on the subjectivity of respondents from the Republic of Korea. Although they were all involved in logistics, they were experienced professionals in the field. The fourth step was the administration of the Q sort. So respondents were asked to sort of prioritize and rank according to the importance each of the 35 statements we produced. In the fifth one, it's the analysis. So we pursued a correlation and a factor analysis. Yet we had to eliminate 5 Q sorts. We had to sort of delete 5 respondents because they did not show any statistical significance within the analysis. And 6, most important, the result interpretation. So very briefly, I will be showing you the results. The analysis was done through the PQM method software. Overall, we had 29 sorts because 5 of them were deleted. And we, via the Q method, were able to extract 3 clusters. So a number of respondents was belonging to each of the 3 clusters. In particular, we found that factor number 1 had 11 respondents. It means that 11 respondents were agreeing overall on the 35 statements they were presented with. Factor number 2, there were 12 respondents, and factor number 3, only 3 respondents. On the right side, as you can see, is a sort of, quickly, a table showing the Q statements that we produced with related z-score. As you can see, we have some z-scores which are positive, some z-score which are negative. A positive z-score means that respondents agreed on the statement. On the other hand, a negative z-score means that the respondents were in disagreement with that particular statement. I'm not obviously going to read through all the statements, but there were 35 in all. You can see that different topics were taken into account. So we took into account logistics issue related to COVID-19. For example, we had a lot of troubles in embarkation and disembarkation of seafarers in China. So this was regionally was a major issue. We took into account something like that, as well as technological issue, data sharing, environmental issues. So there were a lot of, based on literature review, we produced 35 statements. So what are the results? We clustered again 3 groups. The first group of factor number 1 was relabeled or renamed COVID-19 solution seeker and technological denier, because the respondents in this group showed disagreement pretty much on statements related to technology and show agreement on COVID-19 related issue. In particular, they strongly express the opinion of making a faster inspection and medical facility installation, embarkation and disembarkation in ports. Factor number 2 was referred as the COVID-19 cooperation builder and trade cooperation. In this case, as you see, the results are not very different from factor number 1. But what the statement that were mainly highlighted here was faster custom procedure at the regional level for a specific type of necessity goods. So smooth logistics was an important one. Factor number 3, on the other hand, showed different results, and in this case was relabeled digital technology and best practices adapter. In this case, technological issues were mainly emerged from the analysis. As well, from a Q method, we can derive a consensus statement. Those are a few of the statements which all the 3 factors, all the 3 groups of respondents agreed on. That does not necessarily mean that those are the most important ones. This simply shows some consensus amongst the 3 factors. Some of them, for example, as you see, is very much COVID-19 related still, but as well as environmental issues, for example, on industrial ecology, planning or logistics operation, and recycling. So what are the conclusions, basically? So we do understand that the Far East region is an important one in logistics, and cooperation amongst the government is important to ensure smooth logistics operation. Nevertheless, the COVID-19 pandemic has brought new challenges, which have been highlighted from our second step in the analysis. In particular, I drew briefly 3 major implications. Number 1, it was revealed that COVID-19 pandemic emerged as a critical area of cooperation amongst the 3 governments with a focus on improving seafarers' condition. And again, that was very important. The second one is acceleration of adoption of digital technologies and best practices among the 3 governments. Number 3, environmental pressure is on the rise in logistics. Therefore, not only private organization as well as government should be working in that direction. One example, for example, is emission control areas that I think is has been implemented now in a few Chinese coastal areas. Nevertheless, the paper has got some limitation. I focus on one specific regional area, the Far East, but the respondents were all coming from the Republic of Korea. Therefore, there is a bias in this sense. We should get opinions as well from China and from Japan. In particular, we ask respondents coming from the private sector, but I think it would be interesting to extend the responses from government officials. That was my very last slide. Thank you very much for your attention.
Thank you. Very excellent presentation. And I also noticed some very important aspect from your research is digitalization, safe freeway, and environment. So government collaborate on this issue, I think is very important, but not only in Asia, also in other regions. Thank you. So now I would like to invite our third presenter, Professor Dina Karina Disinicu from she is a director of the doctor school at the Business Engineering and Management from University of Polytechnic of Bucharest, Romania. So now I would like to give the floor to Professor Dina Karinas. Please, thank you.
Thank you, Mr. Chairman. Ladies and gentlemen, thank you again for the honor of being on this stage. It's my third time visiting Marlog, and I hope it's not the last because we are like family with our colleagues here. So please let me express my heartfelt gratitude towards the organizers. The organization has been excellent as always. So I would like to thank Professor Soliman, Professor Sandra Haddad, Professor Sarel Gazar, and of course, Amira, which is Engineer Amira Mahdoux, which is our sister. She takes care of us from the beginning to the end until we get home. So thank you very much. Our presentation today has to do with improving the quality of services provided by Romania's greatest, biggest logistics company. And I will try to present briefly. I cooperated for this paper with Professor Sandra Haddad. And we tried to improve these services using the Pareto analysis, which is a widely used managerial tool. Because we approached services, we took into account for the literature review the quality of services. As you know, the services have certain characteristics. They are produced once they are delivered to the customers. You can test them only then when you are delivering them. And a company's success, of course, depends on the quality of services that it offers. And some quality characteristics of the services, of course, credibility, friendliness, safety, and empathy to the customer. So we gain customer loyalty and improve our market share. I will briefly describe the company that we analyzed. It's DB Schenker from Bucharest. It's the #1 freight forwarder in Romania with branches in a lot of our countries, of our cities, sorry. And offers a full range of rail, road, air, and water, sea transport services, logistics, and custom services. I will not insist on this. We just analyzed the turnover and other indicators for the last 3 years. As you can see, the average of the employees number increased in the last year, and it's increasing. A lot of our students are working there. Our research objectives were, we tried to do an analysis on the quality of their services to identify and prioritize the key complaints of the customers using the Pareto analysis and to propose optimal solutions for that. We employed a quantitative methodology. We applied the questionnaire. Our research instrument consisted of a questionnaire regarding different variables, let's say, but for this paper, we only analyzed the complaints of the customers of this company. And the questionnaires were applied online through Google Forms. The method that we applied, the Pareto method, is based on the Pareto principles, which is widely known as the 80-20 rule. It is really helpful because it helps us identify the problem, count their frequency, and identify the critical problems that if we solve that, then approximately 80% of the complaints of the clients are solved. So it helps us identify the critical problems rather than wasting our time and resources managing all the problems. Our research sample consisted of 60 of the most important customers of this DB Schenker in Romania, amongst which I would like to mention 3, Roche, Bosch, and Corning Incorporated. They provided most of the complaints that were analyzed in this study. And this is the final list of the problems reported by customers. Incorrect placement of the dangerous goods or non-hazardous goods, the exceeding transport time, the incomplete documentation, poor communication between the client and the team of the company, poor ventilation of the goods, and the total cost of transport in the end. We tried to discuss with them and identify the causes for each reported problem to understand in detail what can be done about these problems. I will not go into detail each and every problem, but they provided some important input for improving the quality of services. This is the number of complaints for each category. As you can see, the total of the complaints is 60. And you may be familiar with the Pareto analysis. It implies rank ordering the complaints in a, sorry, I have a lapsus now, in a descending order, then to calculate the cumulative frequency and then the percentage, and of course the percentage, because we have 60 complaints, it's a total of 100. Then we draw the Pareto diagram, and as you can see on the diagram, the first 3 complaints of the customers account for 80% of the customers' dissatisfaction. So if we are able to fix and to solve the first 3 problems, then this would be very efficient. The first 4 problems account for more than 80% of the dissatisfaction of the customers. And these are incomplete documentation for the transport, also expanded transport time, incorrect placement of the cargo, and the poor communication between the customers and the import-export team of the company. So if we will be able to fix that, then more than 80% of the complaints will be solved. So discussing with the experts of the company and together with my team, we managed to provide some solutions. For example, for incomplete documentation, we tried to suggest buying a software that would automate this task, and also training the people who are dealing with that. Then we tried to find to plan efficiently alternative routes for if the weather gets bad and the ship needs this. And finally, I don't want to bore you with this analysis that we done in detail for the paper. If you are interested, please read the entire paper. Our final conclusions were that the four most important problems that the customer signaled were incomplete documentation and delaying of the transport time. So these all can be solved with really not easy, but pretty easy method. It's not impossible to do them. So finally, I would like to thank you for your attention. And if you have questions, I would be happy to answer them. Thank you.
So, thank you, Dr. Sorry, I for some name I really have difficulty in pronouncing, but thank you very much. Thank you for sharing us this very interesting case study. I think this is the fourth case study in this presentation. So next will be our friend from India, right? So Dasputta. He's now an assistant professor from India Maritime University. And his topic today is logistic performance as a facilitator to trade performance Indian perspective. We are really interested to hearing this interesting story from you. Now, welcome. Thank you. Yeah.
Thank you, Mr. Chairman. Good morning, ladies and gentlemen. And at the first, I want to express my gratitude to the organizers for accepting our paper and inviting us and giving us this opportunity of presenting our paper here. Now, our paper is co-authored by Mr. Turban Mitro, my colleagues, and Dr. K.M. Patnaik. And the presentation title is Logistics Performance as Facilitator to Trade Performance, an Indian Perspective. Now, let us start with the backdrop. And as we know that with the globalization of the economy of the entire globe, world economy, and now the value chain and the supply chain, every country is dependent on the other, because one manufacturer, he's not only dependent on his domestic activities, but nowadays he can set up his units at different places in the world, and also can get his resources from the different parts of the world. So in this background, the importance of the trade has increased. And obviously, as the major share of the trade, international trade, is bound by the maritime transport, so the importance of the maritime transport is also increased in this respect. Now, so far as the shore part is concerned, here we are mainly concerned about the logistics performance of the individual country, because as a part of the entire logistic chain and entire global trade, they are also very, very responsible for the successful success of the entire trade. And the individual performance of each country is very much important in this respect. Now, this is a picture of the value chain and the supply chain at the international level. We can see that now all these activities are actually is now expanded throughout the globe. And such external dynamics and engagement in international trade would propel the blue economic growth only if backed by strong maritime logistics initiatives and establishment. And as we have mentioned, that we'll be discussing from the individual country's perspective, and in our case, the country question is India. So in this context, deep-rooted challenges, particularly the domestic maritime logistics sector in manufacturing hubs like India, could potentially hamper her competitive advantage in international trade. And that is also true for any other country in the world. So it is in this context that this paper comes as an intercession by analyzing India's logistics performance index and its impact on trade performance. Now, also this paper, besides this, provides a comparative analysis of India's LPI with that of other trade competitors from South and East Asia. We have chosen 8 countries from there and tries to find out challenging areas of maritime logistics for India and suggests the required policy prescription thereof. Our objectives, first to analyze the India's logistics performance index and its impact on trade performance, and to provide a comparative analysis of India's LPI with that of other trade competitors from South and East Asia. Now here, for measuring the logistics performance index, we have taken the data published from World Bank from time to time, because there is no other alternative right now for us. Although this logistics performance index published by World Bank has some weak points and some flaws are there, but in the absence of any other index, we have taken this one. Now the latest one, as of 2023, has been calculated on the basis of performance of 139 countries and based on 6 indicators. They are namely efficiency of customs, quality of trade and transport infrastructure, competence and quality of logistics, timeliness in terms of the frequency with which shipments can reach consignee within the scheduled or expected delivery time, ease of arranging competitively priced shipments, and ability to tracking and tracing consignments. You can get a picture of these 6 logistics performance indicators under the logistics performance index. And 3 of them, as we have seen from the, as you can see from the picture, that they are especially related to the policy regulations, that is the customs, infrastructure, and service quality, and the other 3, timeliness, intermodal, international transport shipments, and tracking and tracing. They are mainly the service part, covering the service part. The methodology to measure this, the present study takes into account a conventional trade function and includes trade facilitation measures to quantify the impacts. In this model, trade flows are a function of gross domestic product, real effective exchange rate, and various indicators of the logistics performance index. That are the 6 indicators that we have just mentioned here. So in total, we have 8 independent variables. And as a measure of the dependent variable, we have taken the container traffic index, and which is also representing the trade of India, both including the export and import and the total container traffic. Now, as we have seen, the first one is the logistics factor, and we have followed the structural equation model, SEM, and constructed 2 latent variables. The first latent variables that we have got from the structural equation model, that is the logistics factors, and it consists of 6 observed variables, which are 6 indicators of the logistics performance index published by World Bank. And the second factor is the financial factors, latent variable, consists of 2 observed variables. One is the real effective exchange rate, which is a nominal effective exchange rate adjusted for inflation. And second one is the constant GDP index at the 2011-12 price. Now, this is our analysis. And as we have seen that below, we have the 2 latent variables, and that is the logistics factors and the effect of logistics factors and financial factors on the container traffic. We can see from the table that both the variables, they have the positive effects and they are significant. And our interest is lying on the logistics performance index. So model estimation shows a positive and significant impact of the logistics performance index on container traffic movement in India. And the analysis of LPI scores for India, along with other. Apart from this, the second part of our paper has considered the comparative analysis of the logistics performance index and taking the scores of the different countries and scores for each and every 6 indicators separately. And by doing this, what we get, that along with other, by comparing this, it eliminates that the major inefficiency of India in logistics performance lies in the lack of proper trade and transport infrastructure and rigid customs and border procedures. So in conclusion, we can say that India's major actionable focus to promote international trade could be external economic integration with major trading parameters partners, coupled with domestic reforms in the customs and infrastructure segments of the logistics and transportation sector. Now, obviously, our government of India has already taken some major steps, and what is reflected in various projects like Gati Shakti and Sagar Mala projects and MIV 2030, Maritime India Vision 2030. And they have already taken many initiatives, and the results of which will be expected in near future. And after that, we will expect really that our performance of India will be much better, much better in this area. And finally, thank you very much.
And thank you, Dr. Dasgupta. Recently, I noticed the container traffic increased a lot in India, but I never heard about what happened inside. But thank you for your sharing. I now understand some story behind. For example, you need to develop the infrastructure to embrace the sudden increase of the container traffic, right? So thank you. And I just noticed now we actually are ahead of our schedule. So our last presenter is Dr. Carolina Hook, and she is from the Logistics and Transportation Department, the International University of Logistics and Transport in Wrocław, Poland. So her topic is achieving sustainable development in logistics, a path to environmental and economic efficiency. And you have enough time, so you can just slow down and explain more if you want. So welcome, yeah.
Thank you. I will try to maybe not to meet the time deadlines, but to give you the short presentation. Good morning still. Dear organizing committee, professors, ladies and gentlemen. First of all, I would like to thank the organizing committee for this opportunity to be here for the second time. It's a great honor to participate in such an excellent event as is Marlog conference, and to be in the group of such an excellent experts today. I would like to present you the presentation, the short speech about sustainable logistics in the logistics sector. Let's start about the concept of sustainable development. The concept of sustainable development has been developing since the 1980s. Sustainable development can be a broadly understood concept that can be interpreted depending on various areas of research. The most popular one, the most popular definition of this sustainable development is the definition that indicates that sustainable development is a development that meets the present without compromising the ability of future generations to meet their own needs. The concept of sustainable development is therefore about searching for a sustainable and parallel development path between economic profit, social harmony, and environmental protection. The main goal of this assumption is to achieve economic benefits, the social harmony, and the environmental protection without damaging people's daily lives and natural resources. The illustration on the slide shows these three elements of economic, environmental, and social development are interconnected. The black point in the illustration represents the space for sustainable development. These three elements of social, environment, and economy were described in detail in the document created by the European Nation Assembly in 2015, and it's called the 2030 Agenda for Sustainable Development. In this document were listed the Sustainable Development Goals to address the challenges facing the global economy, society, and environmental in achieving sustainable development. Of the 17 Sustainable Development Goals listed in this document, I want to present you the three that, in my opinion, concerns in logistics issues. It's Sustainable Development Goal number 7. It's affordable and clean energy. It's Sustainable Development Goal 11. It's sustainable cities and communities. And the last one, the Sustainable Development Goal 12, it's responsible consumption and production. So let's start with the first Sustainable Development Goal. I want to present its affordable and clean energy. Renewable sources power nearly 30% of energy consumption in the electricity sector, but challenges remain in heating and transport sectors. In 2022, for the first time in the history, investments in renewable sources exceed investments in fossil fuels. Globally, in 2020, renewable sources accounted for almost 20% of total final energy consumption, representing a 2.4 percentage point increase from 2015. You can also show in the illustration these results, but it should be noted, and it's illustrated, that the transport sector is the major problem in the use of renewable sources, because compared to 2015, in 2022, there was a very slight increase of only 0.8%. The second sustainable goal I want to describe, it's sustainable cities and communities. Over half of the global population currently resides in urban areas, a rate projected to reach even 70% by 2050. In urban areas, the decline in the poverty rate is slower than in rural areas. More than 80% of global GDP comes from cities, and at the same time, from the cities are responsible for 70% of greenhouse gas emissions. Rapid urbanization can result in significant inequalities in housing, in transportation, and the availability of essentials. On a global scale, there has been improvement in air quality, primarily driven by progress in high-income countries. Addressing air pollution necessitates a shift in mindset, recognizing that it's not exclusively an urban problem. While urban areas remain significant, adopting a comprehensive approach that takes into account small towns and rural areas is essential for effectively combating air pollution. And the last one, Sustainable Development Goals, I want to describe. It's responsible consumption and production. The per capita material footprint in high-income countries is 10 times greater than in low-income countries. The world is also seriously off track in its efforts to halve per capita food waste and losses by 2030. Pollution, the loss of biodiversity, and climate change are caused by, of course, among others, excessive consumption, waste, and inefficient use of natural resources. Between 2000 and 2019, the global domestic material consumption, so it's the amount of raw materials directly used for production processes in a country, increased by 66%, tripling since the 1970s, and reached more than 95 billion metric tons. In 2019, the corresponding material footprint, it's the amount of materials extracted to satisfy final consumption demand in the country, was almost 96 billion metric tons. While the total volumes are similar globally, comparisons reveal regional inequalities in the environmental impact. We can see it on the illustration on the slide. that in Northern Africa and Western Asia, the material footprint in 2019 by the domestic material consumption was 18%, and in Europe and Northern America, it was 13%. While in Latin America and the Caribbean and Sub-Saharan Africa, the material footprint was lower than the domestic material consumption by 17% and 32% respectively. These differences highlight the unequal responsibilities and consumption disparities between import-oriented and export-oriented countries, and generally high-income and low-income countries. The material footprint per capita in high-income countries is 10 times greater than in low-income countries. Therefore, it's essential to adopt sustainable policies and raise awareness to ensure effort and in efficient and sustainable management of limited and equally exploited natural resources by 2030. I would like to go deeper to the logistics, not just sustainable development. So the logistics industry is a sector that plays a crucial role in the increased production of carbon dioxide and consequently in air pollution. Over the past few decades, there has been ongoing research, strategic planning, and social initiatives geared towards addressing the pressing questions of how to minimize the adverse environmental effects of human activity within rapidly expanding economies and growing industries, particularly those reliant on energy sources. Sustainable development is defined as a supply chain management practices and strategies that reduce the ecological and energy footprint of the distribution of goods, which focuses on material handling, waste management, packaging, and also transport. Logistics is a crucial component of the supply chain, yet it's a significant contributor to air pollution. Transported, it's key operational aspect of logistics, but it's also responsible for 24% of global CO2 emissions. To address environmental concerns, there are increasingly strained environmental policies being implemented in Europe and generally in worldwide that are fostering new technologies and innovation in regional and international transportation. Minimizing environmental pollution is a top priority of environmental European Union policies and strategies, and they are extended until 2050. Since logistics refers to the entire supply chains and plays a crucial role from the moment the raw materials are ordered to create the goods until they deliver it to the customer, green logistics practices are identified in terms of different categories with the overall goal of reducing emissions and conserving resources. These practices are directly connected to economic performance. For instance, cutting energy usage by shifting models, adopting eco-friendly driving habits, using alternative energy sources, and effectively managing fleets can lead to cost savings. While initially requiring greater financial investments, the implementation of sustainable practices can enhance long-term financial performance by offering cost-effective services that attract more customers, potentially expanding market size, sales, and profitability. And the last one, the green logistics practices should be applied in the following area of transportation, sourcing, product and packaging design, and administrative issues. When it comes for the first area of transportation, to drive efficiency and sustainability, logistics and transport service providers should embrace new technologies, fuels, and processes that offer a strong economic rationale. They should conduct network assessments of large closed networks to integrate optimization across various networks, encourage collaboration among multiple shippers and carriers, and transition to environmentally friendly modes of transport within their operations. The next area is sourcing, product, and packaging design. And here, shippers and buyers need to assess the carbon footprint of a product by considering factors like the carbon content of raw materials, production processes emissions, supply chain length and speed, and carbon impact during product use. They should also establish standards and goals for reducing packaging weight and waste, and collaborate with other industries to try to standardize modular transit packaging materials. And the last one area I want to describe is administrative issues. So logistics and transport service providers should include carbon offsetting options in the range of services for both the operations and customers. Policymakers should collaborate with these providers to establish consistent carbon measurement and reporting guidelines, create a transparent carbon trading system, and promote wider adoption of carbon labeling. Furthermore, efforts should be made to incorporate the true cost of carbon into energy tariffs for all regions and transportation modes. Thank you so much.
Thank you. We do have a lot of discussion about the emission transaction in Europe right now. Even my PhD student is studying on it. And so this is a very good topic. Okay, so now we have 15 minutes. And first of all, I would like to invite our audience to ask a question to our speakers. So if any of you have any question regarding their topics, their presentations, please raise your hand, then I will let you ask the questions. So are there any questions from our audience? Okay. So if there is no from the floor, then I will ask some question here. Since we have 15 minutes, I have prepared one question, which is a general one, and I would like our speaker to answer this question one by one. Okay, so this is a very simple question, but I think very important. So you may notice the theme, the topic of our session is sustainable logistics, leveraging innovation to improve quality, efficiency, and environment impact. So my question is related to the theme. So my question is that what are the technologies or innovation or management strategy, in your opinion, that may have the most significant impact on maritime transportation? For example, they can improve the quality, efficiency, environment in this industry. I think Professor Shen forced, no, you are not forced. You mentioned the blockchain could be, and I think Dr. Agostini mentioned the integration between different parties can be a very good strategy. So following your presentation, I would like to ask you more about the innovation, technology, management strategy you think which is important to have an impact on the maritime transportation. So this time I think we follow the order from the right to the left. So sorry. So first I would like to ask Dr. Dasgupta to answer my question. So please, yeah. Do we have a microphone here? You may.
In my opinion, I think we may go for the alternative fuels and instead of the fossil fuels, if we can go for the alternative fuels and in my opinion, one of the major factors which may be that the alternative fuels, if we can use it, because for going for sustainable development, obviously it is very, very important. Otherwise, if we are going to continue with the fossil fuels, and we have taken many targets and we have committed, not fully, but so far we are lagging behind our targets. 2030 targets and 2050 targets, we are much below, much lagging behind the targets. And so it is very, very important that we first think about the alternative fuels, which can save the fossil fuels.
Okay, thank you. And you may notice our speaker actually are from different region of the world. So you also can focus on the case in the region you are working or you have worked. Okay, thank you. So now I would like to invite our second speaker.
Thank you. I'd like to take perhaps a broader perspective. I think, well, when it comes to technology, for the integration of maritime transport network, obviously, the big factor today is IoT, Internet of Things, artificial intelligence, automation are all important. But I think what we should look into, we should consider shipping companies, shipping lines as part of supply chains. So I think the game changer is the willingness to share data. If we consider ports or shipping as isolated entity, everyone can collect data. But then are these data shared along the supply chain or not? I think that's the most important one. And I think there was one example which was significant, the project led by Maersk and MSC, TradeLens, which was a sort of data sharing alliance. And it failed. It failed because private entities at the end of the day are not willing to share data. So we can have the technologies there. It does exist, but we need to find the willingness of different stakeholders to share this data. And it's not always obvious, in my opinion.
Thank you. I can't agree more because my research topic is big data application in shipping. So next, I will invite Professor Shen from China to answer my question. Yes.
Thank you. Thank you for your question. In my view, as for your question, I think new technology, innovation in technology is play one of the important role in maritime transportation, such as blockchain. Today, my topic related to blockchain. As we all know, now the word lack of trust. That's very important factors. In fact, maritime transportation across different countries. So how to improve the trust? How to improve? If we just rely on the traditional technology, okay, just like nowadays world. So we need new technology, just like blockchain. The blockchain's characteristics in transparency, traceability, and decentralization. So it can make a great improvement in trust. So different enterprise alliance, they will like share information, share resources, because it will get a new and trust platform to do that. So different country, I think by now a lot of countries' government attach much importance on this technology. For example, United States, UK, and China. Yes, government put much funds, attach much importance in this field. We get many experience and examples. Try to put into practice of this service. For example, in China, investor knew the pyro car exporting. So we use blockchain platform technology and get a very good result in collaboration. And you must know CSC, the Chinese company, shipping company, and the Musky company, shipping company. They are large company, shipping company. They try to use blockchain to solve some problems in maritime logistics. Okay, thank you.
Thank you, Mr. Chairman, for your question. Well, as resulted from our analysis, I would also like to underline the important role of the human resources. Yes, because as you saw, three of the underlying of the identified problems that we had deal with human resources, incomplete documentation, delays, or not so good communication between the client and the technical team. So I think that of course, we need to incorporate all the new technologies, but I think that they will help and they will assist the human resources. The human resources cannot be, overlooked entirely. We should invest in their training and into their development and to understand how to implement better artificial intelligence and the important technologies that were described here. Thank you.
Thank you. It's hard to say something more and add something new to hear my previous speakers. I totally agree with all of you. And what I can say, I think everything will be put together when governments and international organizations will give us the strategies or the policies to push a little bit and motivate entrepreneurs and companies to implement these technologies to their activities. Thank you.
I'm a professor, so I teach a lot. When I teach my students, I always told them, in my mind, maritime is a very historic industry, have a very long historic and a very tradition. So embracing innovation and technology is very, very important for us to sustainable develop this industry. So today we have a hot discussion on this, and I think our presenter gave very excellent presentation, and they all think the data sharing, the human resource, and also the collaboration among all are most important issues we should address in the future for the maritime practitioners and academics. So I will give our audience one more time. If you have some question to our presenter. Okay, if there is no more question, I would like to end the session here. So thank you for your participation. I think after the session, we still can have a discussion with our speakers and with each other. Okay, thank you.
I would like to thank our panelists. I would like to thank our panelists once again for their participation and for their insights. And now I'm just going to ask our panelists to just give us a moment because we're waiting for Professor Ismail because he would like to give you the awards himself. So if you could wait for us for a couple of minutes. As far as the session right now, we are on schedule. After like Professor Ismail arrives, we'll take a very short break, and then our upcoming session will start at 1 p.m. and it's going to be in this room. So we'll just wait for Professor Ismail. And now, Professor Ismail Abdul Ghaffar, Ismail Farag, would like to award our fellow panelists. Dr. Dong Yang, Professor Li Shen, Dr. Enrico D'Agostino, Professor Dana Corina Disilnico, Dr. Mirnal Kumar Dasgupta, Dr. Carolina Vnuk, Now, could the panelists join Dr. Ismail for a group photo? Once again, thank you, dear panelists, and thank you, attendees. So, as I mentioned, we are on schedule. We're going to have a very short coffee break, and we will reconvene in this room at 1. See you then. Hello again. Could our panelists join me on stage, please? Ladies and gentlemen, please take your seats. Please have a seat. Thank you. All right. Welcome back. So this is our final session for the day and a final session before the closing. Since we have merged both rooms, I would like to remind our participants that we have interpretation available if you require. So this session is titled Optimizing Maritime Operations Through AI and Technology. This session is chaired by Professor Maximo Mejia. He's the president of the World Maritime University, Malmo, Sweden. Professor Mejia, you may take the floor.
Thank you, ladies and gentlemen, and welcome to session 8, final session of this wonderful conference. From the Industrial Revolution to the digital age, humanity has consistently embraced innovation as the force that drives progress. And now, witnessing the dawn of the 4th Industrial Revolution, we are poised to redefine the future of our existence. The vast expanse of our oceans presents us with both immense challenges and unparalleled opportunities. It is in this sphere that the convergence of advanced technology, such as artificial intelligence, and maritime services holds tremendous promise. This panel presents a diverse sampling of how these technologies can be applied to maritime operations, how their integration offers us the potential to revolutionize how we interact with, understand, and harness the power of our oceans and the ships that ply over them, the ports that service these ships, and the entire chain that moves international trade from the source of raw materials to the manufacturer and eventually to the consumer. We have a very distinguished panel here in front of us, and I'm very honored to be chairing this session. Let's begin with our first panelist, Mr. Nestor Andre. Ms. Andre is a PhD candidate at the National University for Science and Technology, Politehnica Bucharest in Romania. Ms. Andre is an active duty officer in the Romanian Land Forces. He has a fascination for geography and geotechnologies, and this has led him to delve into the intricacies of spatial analysis, cartography, and Geospatial Technologies. He's presenting the paper, Integrating Artificial Intelligence and Geospatial Technologies for Supply Chain Optimization, that he has co-authored with Professor Cesar Scarlat. Mr. Andre, please.
Thank you. First of all, I would like to thank Dr. Sandra Haddad, Professor Sarah El Ghazar, Professor Akram Soliman, and of course, Engineer Amira Mamdou for their restless effort in making this conference enjoyable event and enjoyable for us. Let me begin to tell you by that our focus derived from comprehensive research, and it's on the technology that are not only enhancing the efficiency, but also significantly contribute to sustainability in the supply chains. Okay. This is the proposed agenda. We'll begin by addressing the complexity inherent in the modern supply chains and the innovative ways to navigate through them. Following this, we will discuss the role of artificial intelligence and geospatial technologies and how they serve as beacons of progress in this domain. We will then transition to their applications, where these technologies have the potential to drive supply chain optimization. A focused case study on the Port of Constanța will provide us with concrete insights into the practical implementation and into its results. To conclude the agenda, we will examine the strategic measures and processes required to harness this technological innovation effectively. This will encompass navigating through potential challenges and leveraging opportunities to fully exploit the capabilities of artificial intelligence and geospatial technologies in the domain of supply chain operations. Modern supply chains face a multitude of challenges, including increasing complexity to the need for greater visibility. These challenges hinder our ability to ensure efficiency and, most of all, sustainability. By understanding these obstacles, we can better appreciate the value of innovative solutions offered by artificial intelligence technologies, offered by geospatial technologies. The fragility of modern supply chains was clearly revealed during the COVID-19 crisis, as businesses struggle with sudden disruptions. The lack of visibility across the supply chain network led to disjoint and often delayed responses to rapidly changing circumstances. This highlighted the essential need for improved transparency and proactive control mechanism within the supply chain to enable swift adaptation to unforeseen events and maintain continuity in operations. Sustainability in supply chains is intrinsically linked to how transparent those chains are. Without clear visibility, sustainable practices are often compromised due to the inability to see and therefore manage each link in the chain effectively. This opacity not only poses environmental hazards, but also endangers the company reputation and its adherence to sustainability regulations. We talk a lot about artificial intelligence, geospatial technology, advanced technologies. But I want to tell you that artificial intelligence and geospatial technologies are not just buzzwords. They are transformative tools that are reshaping how business approach supply chain operations. On one hand, we have artificial intelligence. It's not about replacing human intuition. It's about enhancing it. Through predictive analysis, we can anticipate market trends and demand fluctuation, preparing our inventory and resources accordingly. Machine learning algorithms learn from past patterns to make smarter decisions, to reduce errors and to increase efficiency. And when it comes to making critical decisions, artificial intelligence aids us in processing complex data and to deliver smart data-driven resolution in a very swift manner. Simultaneously, geospatial technology brings a new dimension to the table. Imagine how it would be to have a bird's eye view in the entire supply chain. Spatial data analysis allows us to see the bigger picture and to understand geographical implication on our operations. Route optimization, it's not about finding the shortest path anymore. It's about finding the most efficient, most cost-effective, and the most sustainable one. When we speak about logistic planning, geospatial technology ensures that our strategies are grounded in the reality of the terrain, of the weather, and of the infrastructure restraints. Together, artificial intelligence and geospatial technologies are more than a sum of their parts. They create a dynamic, interconnected system that propels supply chain efficiently forward. This synergy is what we strive for as we harness the power of technology and innovation for supply chain management. With these tools, we're not just keeping the pace, we are setting the pace for what's to come in this industry. I'm gonna speak a little bit about predictive analysis very shortly. By leveraging advanced algorithms and machine learning models, organization can anticipate fluctuations in demand, streamline production, and enhance customer satisfaction. Implementing predictive demand analysis minimizes shortcuts, reduces inventory holdings costs, and improves overall operational efficiency with the supply chain. These advanced technologies enable us to navigate through the variations of market demand, ensuring that our product is agile, our inventory is lean, and our customer satisfaction keeps high. This slide here illustrates the journey from data to decisions. Each step, it's a testament on how artificial intelligence connected with geospatial technologies are not just tools, but they are in fact strategic partners in building a resilient, responsive, and sustainable supply chain infrastructure. Turning our focus towards port operations. You can see on the slide, we have proposed a system, an architecture that uses both artificial intelligence and geospatial technologies such as remote sensing, such as GIS, to smoother port operations. Of course, right now the focus is on the slide. The focus is on autonomous ships, but ships that are now in use can be integrated also into this system. The architecture is comprised of one ashore operation center, which is the main neural network, and connected with more ships neural networks with a lot of processes in between. Each vessel is autonomous in our proposed architecture, and it's equipped with sensors from which I would like to point out the geospatial one that gather raw data on ocean currents, on weather patterns, maritime traffic, and so on. This data, it's feeding the neural system that it's building up decisions to be fed in the navigation, the guidance system of the ship. And this is all done by artificial intelligence algorithms. At the end, it's a clear set of navigational instructions to be followed by the ship in order to optimize port operations. We are now building a small-scale model with a focus on these networks. It's actually a network of networks. I want to say a few things more about the Shore Operations Center. Artificial intelligence neural network that it processes the data received by its sensors both ashore and on the vessel, optimizes the route across the fleet, not just for one single ship, but the whole fleet has the big picture, if I can say like this, the common operational picture of the entire harbor. Or if we are looking at large ports, you can see it as a sector of one port, of course, connected to the next sector, and you can have a smooth transition from one ashore operation center to the other as ships cross by. I want to stress out a few benefits from this. Reduced fuel consumption would be the first one, because the ship doesn't have to wait in that much. Minimize emissions generated by the engines, and of course enhance safety, because we believe that this system could reduce to the minimum human error. Let's explore the impact of artificial intelligence and geospatial technology in the warehouse management. It's a key part of the supply chain. Okay, the question that we have to address is, how can this advanced technology refine operational landscape of our warehouses? Well, the contrast in before integration and after integration, it's quite clear. I'm not going to insist on it. When I want to say that it's not an operational transformation, it is a strategic one. It allows warehouses to evolve from cost centers into strategic assets, driving efficiency and sustainability. Moving forward to our case study, the main focus was Port of Constanța, which is the largest port in Romania. I want to draw a small parallel between where the port of Constanța stands today and where it can be by integrating cutting-edge
navigational and surveillance technologies. I want to focus on the future, and we can foresee the integration of artificial intelligence to further enhance predictive analytics and capabilities. This will allow the port not only to react to current conditions, but also to proactively manage and optimize traffic patterns. We know that recently there's been a lot of pressure on this port because of the war in Ukraine and serial embargo posed by Odessa port. And that made Constanța port the main port to export these goods. So one way it would be to implement technologies that are already implemented in advanced ports, such as Rotterdam port, such as Singapore port, and to blend in all of that into the proposed architecture. Of course, security is paramount. As we incorporate more sophisticated technologies, we gather vast amounts of sensitive data that needs to be handled with cybersecurity measures. For future implication, we need to project into the future. We need to lay out the anticipated implication and exciting new avenues for research in the field and to supply chain management. Our future research will be centered towards leveraging artificial intelligence on risk management and seamless integration on geospatial data for real-time supply chain monitoring, ensuring resilience and sustainability that are the core of the logistics operations, and also developing and implementing the proposed model to demonstrate that it's a real feasible one. Thank you very much.
Thank you, Mr. Andre, for giving us that very educational presentation, giving us an understanding of how AI and geospatial integration can lead to more resilient, efficient, and sustainable supply chains. Our next panelist is Dr. Dong Yang, who is Associate Professor and Associate Head of the Department of Logistics and Maritime Studies at the Hong Kong Polytechnic University in Hong Kong, China. Since 2019, Dr. Yang has been a council member of the International Association of Maritime Economists, IAME, as well as a member of the Port Operation Committee to the Director of Marine in Hong Kong. He was the program chair of the 27th IAME conference in Hong Kong in 2020 and co-chair of the 10th and 11th International Forum on Shipping, Ports and Airports in 2019 and 2021. The paper he is presenting is entitled A Real-Time Port Performance Monitoring System and its Application. Dr. Dong.
Thank you, Chair. So I'm very excited because I can remember last time I presented in so big room, maybe before COVID-19. So I prepare a lot of slides, but don't worry, I'll be very fast today. So today I will present a very successful case of how the research can be applied in the industry to help people, to help government to facilitate their management and efficiency. So you can see my title is a data-driven global port performance monitoring system. It's a system. And this topic is related to how to use a single source data, AIS, to generate a lot of statistics. So as I mentioned, I prepared so many slides, so I will skip this one. Why we have this study? Because we noticed as an empirical study researcher, we always suffer from data problem. For example, if you look at the port throughput data, you may find it's always published delay with low efficiency. And for some countries, they are unavailable and insufficient. So with more and more data emerged, like AIS, like other data, we are curious if we can use the single ship data to generate more statistics, shipping data at the global level. And then we started to do it. So for this topic, we have published a lot of papers in very high-ranking journal. We published a paper in Transportation Research B, Transportation Research Part C, and also Journal of Transportation Geography, and also IEEE Intelligence Transportation. They are all top journals in the academic field. But I would to highlight here, all this research are not stay at the paper. We finally transfer them to be a real product. So that's something I'm proud to say here. So, okay, this picture also shows the main function of our system. It's including to port congestion. What this means? This means we can estimate the real-time port congestion for the global port in few seconds. And also port productivity and the port connectivity, port skipping identification, that is a service disruption, and also destination prediction. All this function has been realized by us in real time. And we now is constructing a platform to include all the function. So I would like to start from, okay. Actually, the United Nations organized a big data hackathon. Is organized by the UNCTAD and some other enterprise. So they organize this competition, and we use our concept attended this competition. And among more than 50 teams, we finally ranked number 3 among all. So this is a big award from United Nations. So here I will briefly explain the function. So from the first, we like to estimate the port congestion. Port congestion was very serious during COVID-19, for example, in Los Angeles port. But if try to look for the data of port congestion, you cannot find it basically. We have checked. So we are thinking if we have individual ship data with time, with the location, we can do it. So we use a clustering algorithm to lay out the accurate area for all the ports of the world. So after that, we can simply, sorry, my slide disappeared. So, okay. So with this area, we can simply calculate how long a ship waiting at this area. Then we know the congestion level of all the port. Of course, we use some well-designed algorithm to realize that. For example, we even consider the heading of ships, because you may notice the heading of ships in the anchorage area and in the berth area are totally different. So we also use this to identify the anchorage area of all over the port. Then we simply calculate the waiting time. So this picture shows we can precisely identify the berthing area and anchorage area of the port all over the world in few seconds. Then we simply calculate the waiting time of a ship in this area. So this is an example. So we estimate the average congestion time of top 20 ports in 2020. So you may say in the November and December of 2020, the Los Angeles was seriously congested. The ship averagely waited for 80 hours to be burst. If you look at the Chinese port, you can see the Ningbo Zhoushan port is relatively congested, but most of Chinese port is okay. We also calculate the average congestion rate of top 20 container port. And this is a function one. Function two, we estimate the production or productivity of all over the world, or I mean the port. And the simply idea is the productivity of a port can be calculated by the operating time divided by the throughput, or the throughput divided by the operating time. And we also develop some algorithm, and we use our way to identify the berthing area. And finally, we can generate the productivity of all over the port. And in 2020, during the COVID-19, we can say Shanghai ranked #1. That means Shanghai had the best efficiency in port operation, followed by Ningbo Zhoushan. And Singapore is also good in terms of port productivity. And beyond that, we also calculate the port connectivity. Some of you may be aware the connectivity index is very important. And the UNCTAD, the United Nations, and the Logistics Association publish the connectivity index every year at a yearly level. But if we look at their index, you may find that the index consider the ship visit number, the service the shipping line provided, and also some data they collected from consultant company. But there are some indicator absent which are important. What is that? Is the one which describe the network. So based on all the indicators they consider, including vessel visits, connected countries, we further consider some very important indicator like the degree centrality, close centrality, between centrality, and the strategic importance. You can find this detail from our paper. This is quite important because these indicators describe how important a port in the network, but not only the throughput, the connected country. And then we calculate the index. We have some interesting finding. So in the index system, issued by United Nations and also the Logistics Association, the Hong Kong and Antwerp in Europe, the ranking are not as high as this because they have relatively low throughput, relatively low ship visit. But in our system, their ranking are relatively high because they have very good connected characteristics, connected in a shipping network. So we can further give more detailed analysis regarding the connectivity. For example, how is the ship visit number, ranking of ship visit number, how is the between the centrality. So this provided a more comprehensive indicator of connectivity to the regarding the port. And we also show the change of connectivity during COVID-19. So you can see many of the ports suffer from COVID-19, but some suffer more than others. Okay, so I will go faster. So this is what we get from our research. And now we also develop a function to identify the port scaping. For example, a shipping service is normally from A, B, C, D, right? Sometimes because the port C is congested, the shipping line simply skip the port C. So that becomes ABD. Then we can tell you how many ships skip one port in real time. So we also develop some algorithm on this. Yes, we do. And finally, we also it's very interesting. when we have the forecasting or the estimation of port escaping, we found a different interesting pattern shipping line adopted to scale port. They scale port, for example, they replace the order of two ports, or they just sometimes simply skipped one port, or they change the ship between different service. These are quite interesting. All this can be realized in our system. So I will jump to the final slide. We also can forecast the destination of ships. Okay, we can. Okay, there's one more slide represented here, but let me summarize. We are construction a planned form, a Weber site, which include all these functions. And I can give you the Weber site. You can try. Now the Weber site is the interior, and the Hong Kong government funded us to build up this Weber site. So in the near future, I think this Weber site can become very smooth, and you can use this function from this Weber site in the future. So that's all my presentation. Thank you. Thank you. That's all. Thank you.
Thank you, Dr. Yang, for sharing with us not only your research but also application, looking at how through AIS you're developing some innovative methods to generate port statistics at a higher frequency and at the global level. So thank you. On to our next speaker. Our next panelist is engineer Miral Armanius, who is a graduate teaching assistant in the Marine and Offshore Engineering Department here at the Arab Academy of Science, Technology and Maritime Transport. Engineer Armanius's research interests lie in the field of proactive maintenance for marine systems, with a particular focus on developing innovative solutions for identifying and preventing main engine failures. She explores the use of advanced data analytics and condition monitoring techniques to predict and address potential engine issues before they escalate into very costly downtime or safety hazards. She will be presenting the paper, Development of a Proactive Maintenance Plan for Failure Identification in Ship Engine System, which she has co-authored with Dr. Ahmed Mehana, Dr. Shireen Nagy, and Dr. Ahmed Shahata. Please, Engineer Armanius.
Hello, everyone. It's such a great honor to be here in the International Maritime Transport and Logistics Conference, Marlog 13. Thank you so much. Our presentation today will be for the paper titled Development of Proactive Maintenance Plan for Identification of Ships' Main Engine Failures. My presentation contents will be the introduction and background of our research, our aim and objectives, the methodology we used, and the results and their discussion, and finally the conclusion and future work. Ocean shipping accounts for 90% of the global trade in the world, which accounts for 72% of them in value and almost 90% of them in volume, which makes the shipping industry crucial to global trade. This cruciality leads to the industry's impact by maintenance procedures that work to ensure the profitability and dependability of the industry. This led to the importance of maintenance procedures on board ships to create an eco-sustainable maritime industry and ensure the safe operation of ships. And one of the most important components on board a ship is the main engine. The main engine ensures the continuous operation of the ship, and that's why its maintenance is crucial. Given the various factors that affect the ship on its route, such as weather conditions, as well as the standards laid by the industry, the maintenance procedures sometimes fall short of achieving the reliability goals desired. This results in a lot of downtime for the equipment, as well as the increased failure rates, and this reflects on the higher emissions of the engine, as well as the costs of the operation. Due to these problems, a lot of research have been done to research the maintenance approaches in the maritime, used in the maritime industry. For example, in 2010, Afifi and others researched reliability-centered maintenance and its optimization to improve performance and safety, which resulted in a maintenance cost decrease of 30%, as well as a reduction in equipment failure by 25%. Also in 2021, Ingmar's daughter and others were using condition-based maintenance and found difficulties in implementing it due to the lack of accurate data, as well as unqualified staff members. More recently, there have been research about machine learning-based maintenance and its use to improve the maintenance conditions on board ships. For example, in 2020, El Shamaroni investigated using remote monitoring techniques and data processing, such as the Internet of Things, to reduce the maintenance costs by 20% and increase the equipment availability by 15%. More recently, in 2023, Payat and Abdel Noor used machine learning applications such as pattern recognition to predict future events before they occur, which resulted in a 24% increase in equipment reliability and 15% decrease in maintenance costs. Given all this research, either in maintenance approaches or the use of machine learning in maintenance techniques, the maintenance strategies fall short of prioritizing key actions, especially in marine diesel engines. Also, as we need to integrate more state-of-the-art technology into the current maintenance strategies and study how they comply with the current policies, compatibility, and affordability. Given the research gap that we found, this research aims to use a proactive maintenance plan specified for marine diesel engines to classify their failures and increase the dependability on the engine. This aim will be carried out through two objectives, the first of which is an experimental investigation of different failures mode that can occur for a diesel engine, and we will monitor the subsequent temperature changes due to these failures. Secondly, we will create or develop a machine learning model that works to classify the gathered data and choose the failure rate, which we will then use to schedule maintenance procedures accordingly. To achieve these aim and objectives, we constructed a methodology that consists of 5 phases. The first of which is the survey and data collection, which we already discussed. The second is the experimental model for the engine failures, and then the machine learning algorithm and integrated experimental data and machine learning code, and finally, the analysis of the gathered results. First, for the experimental setup, we used a small diesel engine that was air-cooled, a 4-stroke single-cylinder diesel engines, the specifications of which are shown on the screen. We conducted 2 failure modes for the engine. The first one was an air filter blockage, and the second one was a reduction of the lubricating oil levels. And the impact of these failures was noticed by changes in temperatures, which were measured using 2 sensors, 2 temperature sensors on the engine cylinder head, as well as the exhaust gas manifold. and the results for the normal operation as well as the two failure modes were recorded. Secondly, for the machine learning model, we collected these temperature readings and used a 5-fold cross-validation partitioning scheme to use to train and test various machine learning models, which are the logistic regression, random forest, support vector machine, k-nearest neighbor, naive-based decision tree, multi-layer perceptron, and Adam boost models. The various machine learning models were therefore assessed based on the shown equations, which were the accuracy and precision, recall, and F1 score, to determine the best effective model for the classification of the failure modes. The coloration matrix shown shows the correlation between the different features that we have, which are the temperatures of the cylinder head and the exhaust gas manifold, and the class, which is the failure condition. This correlation matrix shows that the temperatures show a strong correlation, while the correlation between the temperatures and the class is small, which makes this classification of the failure modes very challenging given the features that we have. For our results, starting with the experimental results, the table shows the normal operating conditions results for the main engine, which was run for 10 minutes. And the data shows an average exhaust gas temperature of around 50 degrees Celsius and an average cylinder head temperature of around 25 degrees Celsius. For the first failure mode that we have, which is the air blockage failure mode, the temperatures were collected for various percentages of blockage, which are 20%, 40%, 60%, and 80%. And it was noticed that there were a great fluctuations or increase in the temperature than the normal operation condition. For the oil level failure results, we changed the oil level by 3 percentages, which were 75, 50, and 25. And we noticed that the temperature changed slightly, which makes the classification of the failure more difficult in this case. For the machine learning models, we researched a couple of models, and we used the data we collected to train and test these models. And the results were mainly based on the accuracy of the model and the macro average F1 score. The results showed that the decision tree model achieved the best accuracy in determining the failure mode, followed by the random forest model and the naive Bayes model. To conclude, this research aimed to make use of machine learning models to classify different engine failures, engine signs of failure, and we noticed a strong deviation from the normal operating conditions in both failures. And while investigating the various machine learning models, we noticed that the decision tree model achieved the highest accuracy of almost 90%, as well as the average F1 score of 0.8, which means that the decision tree model was the most successful in correctly predicting the failure mode. Further research on this topic will involve examining more failure modes, working on a larger diesel engine to kind of reach better results as those that will be on board an actual ship. We also would like to investigate more parameters such as marine vibration, machine vibration, and engine load and their impact on the models. We also would like to use deep learning models and time series analysis, which can help us more in predicting the failure even before it happens. And we can work, therefore, to kind of eliminate failures before they even occur. Finally, I would like to express my sincere gratitude to the faculty members of the Marine and Offshore Engineering Department. They have helped greatly in this research. I would like to specifically thank Dr. Ahmed Samir, who is the head of the Marine and Offshore Engineering Department, and Dr. Shireen Nagy, an associate professor in the Computer Engineering Department, for their great contribution. I couldn't have done it without you. And that's it. Thank you.
Thank you, Engineer Armanius, for your presentation and for sharing with us this proactive maintenance strategy model that you've tested and found yielding a better maintenance schedule and more effective fault identification. So I really wish you good luck in your continued research that you laid out in your last slide. So now we turn to our final panelist for this session. And we have Dr. Eman Hamdan, who is Associate Professor of Electrical Engineering and Vice Dean for Postgraduate Studies and Scientific Research in the College of Maritime Transport and Technology here at the Arab Academy of Science, Technology, and Maritime Transport. Her research interests include control applications in electrical smart grid, automatic control applications, coding techniques in MIMO networks, and multi-sensors networks. She will be presenting the paper Pilot-Assisted Underwater Acoustic Channel Estimation for MIMO OFDM systems using sparse Bayesian learning algorithm, which she has co-authored with Ms. Asma Yahia. Please, Professor Eman.
Good afternoon. First of all, I want to thank Engineering Asma for her help and support in this research paper. I will not take all the time, just 10 minutes, and I will finish, inshallah. This paper is the pilot-assisted underwater acoustic channel estimation for MIMO of OFDM system using sparse Bayesian learning algorithm. The outline of this paper will be first of all, we said the objective of this, and then we will talk about why we use underwater acoustic communication. And then we show the characteristics of the underwater acoustic channel. Then we will explain the MIMO OFDM communication system we already use in this research paper. Then we will explain the modeling of underwater acoustic channel we used in this research paper. The last thing, we will compare between the proposed channel estimation algorithm we use. Finally, the simulation result and the conclusion in the future discussion will be presented. The objective of this paper is to search the effect of the channel estimation with using an already made model for the underwater acoustic channel. We will use 3 different models and then compare between them and choose which proposed system is the best in underwater acoustic channel. The underwater acoustic channel estimation and communication system is very important in different things like in ocean exploration and the commercial and the industrial application. Marine communication can use this system and in environmental monitoring and to prevent any disaster, and also in underwater infrastructure maintenance. To study underwater acoustic channel, we have to know these characteristics of this kind of channel. We have a propagation loss and attenuation. The channel is a limited bandwidth because it's frequency dependent. Also, there is a multipass propagation and lost and most important was the sparsity of the channel. This is the system we use in our study. This is a MIMO of DM communication system. We already choose MIMO of DF system to enhance spectral efficiency and to improve the data rate. And for the multipass mitigation, as you see in this graph for this block diagram, it represents the transmitter and the channel, also the receiver. Here, we depend on inserting the pilot in certain place, which all the channel estimation depending on this kind of insertion and the position of the pilot. This is the model we have used to create our underwater channel. The table here shows the main parameter we are depending on modeling. All these parameters must be inserted in our simulation to create this kind of channel. All the parameter is inserted and simulated and give us the impulse response shown in this graph. 3 proposed channel estimation approach are used. The first was the traditional method by using least square, but here a large number of samples required for channel estimation. He discarded completely the sparsity of the underwater acoustic channel, which caused the computational complexity was higher than the other type, which is the compressed sensing. In the compressed sensing, we use 2 kinds of method. First of all, compressive sampling matching, persuade COSAMP, and sparse Bayesian learning, SPL. In this, sparse signal can be estimated using few significant coefficients which reduce the complexity of the system. This explains the steps we used in our compressive sampling matching persuade. Here is depending on making an initial value and then make iteration to estimate an accurate value for the channel. This is compared with the second one, which is a sparse Bayesian learning algorithm. The simulation here to discuss between the 3 different types. As you see, when we find the mean square error for channel estimation and the bit error calculation, that the SPL system was preferred than traditional method and the co-sampling method. And also for the bit error rate, as you see, this red line represents the SPL system. Another discussion here was made if we arrange the pilot inside the transmitting signal. Can we use a regular arrangement or a scattered arrangement? We found that scattered arrangement is much better than, regular arrangement was better than scattered or random arrangement. As a conclusion, here we illustrate 3 types of underwater acoustic channel. We compared between the least square error and the co-sampling and the SPL, and we found that the sensing algorithm is compressed sensing algorithm is much better than the traditional methods. Okay, and for the SPL, if we use a pilot arrangement is regular, much better than a scattered arrangement. For future research, we can use this Bayesian-based compressed to enhance the estimation of the underwater channel by differentiating the position of the pilot. Thank you all.
Thank you, Professor Hamdan, for presenting us with your findings on how compressed sensing-based approaches provide more effective channel estimation. So there we have it. I think we've really benefited from a wide range of different presentations, looking at how advanced technologies, IT, how they can be used to apply, how they can be applied in order to optimize maritime operations. So now I'd like to thank our panelists also for keeping accurate time. We finished the presentations with an average of 15 minutes each, and this leaves us with around close to 20 minutes for discussions. So I'd like to open the floor to any questions, please, from the audience. And I'd like to welcome questions from the audience, because otherwise, I think we will ask the audience questions to check if you have been listening. Please, Professor.
Thank you very much for this actually very interesting section. I am very happy to see this kind of excellent presentation. My question to Miral. You have new approach, which I just notes from the presentation. But what is your plan for the next step of this research? I mean, how we can implement and how can this research be effective in the industrial point of view?
Thank you, Professor. So please.
For the implementation of such a system on board actual ships will involve the use of various sensors, which can gather more information from various parameters that can then be used in these machine learning models, whichever model we choose to use. And this can help us either detect these early signs of failure based on the normal operation results and the results used to train and test the model with failure readings from these various parameters.
Thank you. Any more questions from the audience? Oh, yes, please.
Mr. Nestor, AI is very hot topic these days, and I was happy to see how you can implement AI techniques in the supply chain optimization. I'm not sure if you have make a scan for the Arab and Egypt ports or not, but we need your advice, your guidance, how we can use these new techniques to improve the supply chain, the logistic of supply chain, especially in these days with the Red Sea problems having these days.
Thank you, Professor. So I would say the main key to this would be standardization. So we have examples of very high-tech ports, but we see that the operations in those ports are very different from one another. This is because the technology is advancing way faster than we can regulate and standardize things. So I think the key is standardization and working together towards a smooth link from production, loading, transportation, unloading, and last mile transportation towards the final client. Thank you, sir. I hope this answers the question.
Thank you.
As no one else want to ask, can I ask the last one, please? Dr. Donggang. It's my pleasure to. I think you are the first presenter in Marlog from Hong Kong. We received from China before, but maybe you was the first one in Marlog who present a paper, and you originally from Hong Kong. So thank you very much for coming to us. And really, it was very interesting topic. Real-time blood board performance monitoring system and its application. You know, the Marlog conference usually connect the industry with the academia, and in our beliefs that we're trying to have applied recommendation, which can be implemented in the boards and can positively affect their performance. So if I ask from you, what you recommend from paper to be implemented in our boards?
Sorry, can you repeat your last sentence?
I ask you to recommend to us one recommendation. We can use it and implement in our boards.
Okay, so this is my first time attended the Marlog. Actually, I'm very impressive. It's very impressive to me because I met a lot of people, both from industry and from academic. I think it's a very good chance to gathering this kind of people to talk and communicate. But as I mentioned, if there is one recommendation, I think you may promote the conference in Asia more in the future, because in Asia we have very good maritime community, and we also like to communicate with the Middle East, to the world, and to help each other. So next year, I hope I can help. Of course, we can promote more of your conference to our Asia colleagues, and we can bring more people together to communicate, to look for collaboration in the future. Thank you. Thank you for your question. Yeah.
Usually our pleasure. I will wait for your invitation, and I will do my best. We organize different events in out of Egypt, but it will be the first time to make it in Asia, in Hong Kong. Well, why not? Let's be in touch. Thank you very much.
Yeah, thank you very much. Yeah.
Thank you. I have a question for actually have a question here for Associate Professor Hamdan. You presented a few different approaches, but why do you prefer the sparse Bayesian learning in terms of to apply in channel estimation?
Because it doesn't need to know the sparsity level we are in this estimation for the channel. We neglect this and we didn't use this sparsity level. So the assumption comes to us in the calculation more accurate than if you estimate this value.
Okay. Well, thank you. Thank you for that answer. Do you have any more questions I'd like to ask? I have one for Mr. Andre. You presented some technologies and you shared with us the architecture that you've been working on, maybe you've been developing. So what do you think would be a focus point in applying and implementing these?
Sir, so first of all, I think we should gather as much lessons learned from the advanced ports, and then we should leverage the path to make the implementation smoother. I again get to the standardization, which will not gonna keep the pace up with the technology. I can tell you that even from our research, we had to rewrite the code a few times because the older libraries are obsolete so fast in artificial intelligence. So we need to set the pace with the technology first, and then to smoothen the path for the technologies to be implemented. Of course, this involves costs. All technologies involves costs, but I think on the long term, the benefits will overcome this cost by a great amount. And I think that having ports connected, competing but also cooperating is the key to implement new technologies and to advance in supply chain management and in trade in general.
Okay.
Thank you, sir.
Thank you. Thank you. Another one for Professor Yang. Your presentation your presentation focused on the criticality of innovation in the maritime industry. So what challenges do you see or foresee in terms of implementing innovation?
Thank you. Very good question. And yes, there is a huge challenge between the theory and the implementation of the innovation. In my experience from the industry side, because shipping is an old industry with 100 years for history, and they adopt a very traditional pattern of operation, business pattern or something like that. So when I get in touch with the maritime practitioner, I feel they actually are not likely change a lot for the traditional operation way, unless there is no cost. Yeah, I mean, the cost not only money, but also they follow the way. They don't want to make any change on the way they get used to. Okay, so in another side from the academic world from us, I feel there is a challenge. One is that we are not good enough. Sometimes we develop some model, but we honestly do not have a comprehensive, in-depth understanding of some certain maritime industry. So our model sometimes is not well designed to be put into practice. So considering this, I think the way to overcome the challenge is that first of all, we should communicate more. We should create chance, create opportunity for communication, and also I think maybe we should seek for help from some third party, like some association, some consultant company, or some third party. They may play a real role in bridging us to the industry. That's my answer. Thank you for your question. Yeah.
Thank you, Dr. Yang. And again, back to your invitation earlier, bigger network, Asia, Middle East. And I have one more question for Miral. The temperature readings that you shared with us in your presentation. Do you find that these are normal for a marine diesel engine used on ships?
So the temperature readings we used were for the small diesel engine that we experimented on. But while these temperatures will not be the same for an actual diesel engine used on board ships, the study was much focused on the increase in temperatures, which was affected by the failure modes applied on the engine. So usually these temperatures will change based on the size of the engine, but it's the increase in the temperature compared to the normal operation that is what makes us or the model able to detect these early signs of failure.
Okay, so it's really the rate of change, as it were, that, okay. Thank you very much. And I have one final question on the MIMO paper. So why do you expect that regular arrangement is better than scattered or random arrangement?
As I said, underwater acoustic channel is a frequency dependent. So if we see the impulse response of this channel, there are coefficients that have a high power and the coefficient we can neglect the power. So if we put a scattered system, we can neglect the pattern which contain the most power we need to calculate. But if we put a regular pattern, in this case, we will be sure that the main high power which we are thinking for in the impulse response are included in our result.
Okay, thank you very much. Okay, thank you very much. Now I'd like to open, because we still have a few minutes. I just want to check if there are any follow-up questions from the audience. Otherwise, I'd like to thank the distinguished members of this session for really elucidating on these different points of their research relating to optimizing maritime operations through advanced technology. These are only some of the areas where we can expect maritime operations really to move to the next level and also to overcome the many different challenges that is being put before it, not the least of which is, of course, the effort to decarbonize the industry. So I'd like to request everyone to please give a warm round of applause to our panelists. Yeah, thank you very much for an excellent panel, and thank you for listening.
I would like to thank our panelists once again. I would like to thank our attendees. And now, Professor Ismail Abdulghaffar Ismail Farag would like to award our panelists. Mr. Nestor Andrea. Dr. Dong Yang. Engineer Miral Armanios. Dr. Iman Hamdan. Now, could our panelists join Dr. Ismail for a group photo? Ladies and gentlemen, السيدات والسادة، الآن توقيع اتفاقية تعاون بين معهد تدريب الموانئ الأكاديمية العربية للعلوم والتكنولوجيا والنقل البحري والشركة الليبية للموانئ في ليبيا. إن الشركة الليبية للموانئ تقوم بإدارة وتشغيل 8 موانئ ليبية. تهدف هذه الاتفاقية إلى إيجاد الإطار الملائم بين الشركة والمعهد في تنفيذ البرامج في مجال التدريب والاستشارات للشركة. يوقع على الاتفاقية الأستاذ الدكتور إسماعيل عبد الغفار إسماعيل فرج، رئيس الأكاديمية العربية للعلوم والتكنولوجيا والنقل البحري، والأستاذ محمد علي حمدان، رئيس مجلس إدارة الشركة الليبية للموانئ. Ladies and gentlemen, we thank you for tuning in, but stay right where you are because our closing session shall begin shortly.
تفضلوا بالجلوس لنبدأ بالجلسة الختامية. I'd like to invite Dr. Akram Suleiman to join us on stage. Translation is available for the closing session from Arabic to English. أبحرت سفينة مارلوغ على مدار 3 أيام طوال فترة انعقاد المؤتمر، وأوشكت أن تصل إلى الميناء وترسو بنجاح. نختتم اليوم فعالية المؤتمر الدولي للنقل البحري واللوجستيات بنسخته 13، حيث شهدنا على مدار 3 أيام العديد من الأحداث والجلسات العلمية المتميزة والمشاركة الفعالة من جميع المشاركين. وها نحن نصل الآن إلى الجلسة الختامية لمؤتمرنا الدولي مارلوغ بنسخته 13. عنوان Towards Smart Green Blue Infrastructure. ذلك المؤتمر الذي عقد هذا العام برعاية كريمة من معالي السيد أحمد أبو الغيط الأمين العام لجامعة الدول العربية، ومعالي الفريق كامل عبد الهادي الوزير وزير النقل بجمهورية مصر العربية. واحتضنته الأكاديمية العربية للعلوم والتكنولوجيا والنقل البحري على مدار 3 أيام، والذي ضم مجموعة كبيرة من الخبراء وصناع ومتخذي القرار، حيث ناقش نخبة من الباحثين المتميزين من مختلف دول العالم العديد من الأوراق البحثية الهامة. والآن يسعدنا أن نقوم بعرض فيلماً يوثق أحداث النسخة 13 من المؤتمر الدولي للنقل البحري واللوجستيات مارلوغ.
والآن يسعدنا أن ندعو سعادة الأستاذ الدكتور إسماعيل عبد الغفار إسماعيل فرج رئيس المؤتمر ورئيس الأكاديمية العربية للعلوم والتكنولوجيا والنقل البحري لإلقاء كلمة الختام لفعالية مؤتمر مارلوج 13. فليتفضل.
بسم الله الرحمن الرحيم. يعني حقيقة كل الشكر وكل التقدير وكل الاحترام لكل اللي فعلا اللي قاموا بالتجهيز والإعداد الجيد لهذه النسخة من مؤتمر مارلوج على مدار عام. جهد عظيم. كل الشكر وكل التقدير لكل الزملاء أسرة الأكاديمية. كل الشكر وكل التقدير لكل أصحاب المجهود في الإعداد الجيد علميا وإداريا وتنظيميا للوصول لهذا يعني يعني حقيقي المشهد رائع اللي احنا شفناه على مدار الثلاث أيام الماضية. لم يكن ليتحقق لولا هذا الجهد الكبير. فشكرا لأسرة الأكاديمية، شكرا لكل الزملاء أعضاء اللجان المختلفة للإعداد والتجهيز للمؤتمر. أنا عارف إن هم عدد كبير جدا فمش هقدر أذكر أسمائهم، لكن كل الشكر وكل التقدير طبعا الأستاذ دكتور أكرم سليمان. شكرا جزيلا دكتور أكرم. شكرا الاستاذ دكتور علاء مرسي. كل الشكر وكل التقدير لحضرتك. حقيقي الزملاء الاعزاء اكرم وعلاء ومعاهم طبعا فريق عمل متميز ورائع في كل مكان في الاكاديميه وكل الكليات والمعاهد اللي في الاكاديميه وكل القطاعات المختلفه. مجهود كبير، ثقه كبيره جدا. فشكرا جزيلا. المعرض ايضا كان رائع جدا، فشكرا للسادة العارضين وشكرا برضو للجنة المنظمة للمعرض. طبعا أكيد شكر خاص للحضور الرائع اللي أنا شاهدته. وفعلا يعني الحضور اللي شاركوا بالأبحاث واللي شاركوا ككينوت سبيكرز ليهم مني كل الشكر وكل التقدير. فعلا حقيقي وجودكم أثرى المؤتمر بشكل كبير جدا. يعني مقالات علمية متميزة سايتد في واحد من أفضل المواقع السيتيشنز. ف يعني حقيقي كل الزملاء وكل الحضور من كل all over the world، من كل دول العالم ومن وطننا العربي اللي شرفونا وشاركونا على مدار هذه الأيام. حقيقي يعني كل الشكر وكل تقدير لحضراتكم والإعلام والمتميز الرائع اللي شاركنا على مدار هذه الأيام. طبعا أكيد يعني حقيقي الواحد فخور وسعيد جدا بالهيومن كابيتال اللي الأكاديمية العربية بتملكه النهاردة. حقيقي شايف ولادي وهم بيقدموا الجلسات، ولادي وهم بيترجموا الترجمة الفورية، ولادي وهم بيقوموا على كل تفاصيل المؤتمر مع أساتذتهم وزمايلهم. شيء يدعو للفخر. والكمان بقى المنظومة اللي هي الرائعة من أصغر خريج الأكاديمية بيقدموا مقالات علمية متميزة وسط أساتذة. يعني الواحد هو شايف ميرال وهي قاعدة جنب رئيس الجامعة البحرية الدولية وبتقول مقالة علمية. فحقيقي شيء يدعو للثقة. أنا مطمئن وسعيد لما وصلت إليه الأكاديمية العربية للتكنولوجيا والنقل البحري. بطمئن، قلبي بيطمئن فعلا على المستقبل رغم كل التحديات. لكن أنا أعتقد أن اللي احنا وصلنا له في السنوات الماضية يؤكد فعلا على إن شاء الله استدامة هذا الصرح العلمي العربي المتميز حتى يظل أن يكون تحت خدمة أمتنا العربية كلها، يقوم يعني بدوره بتميز وباقتدار. فشكرا لثقة كل الحضور من دولنا العربية من كل الدول. شكرا طبعا أكيد ثقة القيادة السياسية وثقة الحكومة المصرية. وإحنا شايفين يعني في الجلسة الافتتاحية منصة يعني أعتقد تعبر بكثير وكثير عن مدى تقدير يعني الدولة المصرية والدول العربية للأكاديمية وجامعة الدول العربية للأكاديمية. شفنا يعني تشريف كل أصحاب المعالي، طبعا معالي الفريق كامل الوزير، وزير النقل المصري رغم كل مشاغله لكن حرصه على ان هو يكون معانا وتأكيده على ان هو منتظر لتوصياتكم عشان يعمل عليها مع الزملاء في وزارة النقل في مصر. حقيقي شيء رائع. طبعا تشريف معالي المحافظ، معالي الفريق أسامة ربيع، لا أريد أن أذكر الجميع لأن يعني حقيقي قائد المنطقة الشمالية العسكرية. هو ده بيأكد الثقة في هذا الصرح العلمي العربي المتميز، بيت الخبرة العربي، البحث العلمي، جودة التعليم، التدريب، الاستشارات. حقيقي الاتفاقيات اللي احنا وقعناها برضو بتورينا قد ايه الطموح في هذا الصرح العربي المتميز. فشكرا لكل دولنا العربية، شكرا لجامعة الدول العربية، شكرا لرعاية الدولة المصرية، شكرا جزيلا لكل التاني، كل المنظمين وكل المشاركين من كل دول العالم. أكيد تعبتوا عناء السفر لكن أنا بشكركم. أتمنى تكونوا استمتعتوا بوجودكم في مارلوج، استمتعتوا بالجلسات العلمية، استمتعتوا بجو مصر الرائع في هذه الأيام، استمتعتم بالاسكندريه الجميله عاصمه الثقافه والحضاره والعلوم والفنون. ان شاء الله رحله عطاء متجدده مستمره، رحله الاكاديميه العربيه 52 سنه ارب اكاديمي، 13 سنه مارلوج، لكنها رغم ان بنقول وصلنا للختام، لا، بقول احنا لسه مستمرين، هي محطة من محطات العطاء. فبدعو كل أسرة الأكاديمية وبدعو كل المشاركين ان هم يظلوا معانا، يظلوا مشاركين، يظلوا متواصلين في العطاء. المؤتمر ده بيعكس قد ايه احنا مع بعض فاميلي واحدة، أسرة بيجمعها، يعني رغم كل التحديات اللي احنا بنشوفها حوالينا وقريبة جدا مننا، لكن أكيد شركاء نجاحنا من كل دول العالم بشكرهم على تحملهم عناء السفر ووجودهم معانا على مدار هذه الأيام. شكرا جزيلا ليكم. شكر خاص بروفيسور ماكسيمو رئيس الجامعة البحرية الدولية، يعني تقدير خاص لسعادتك على يور اكسلنسي على تشريفك لينا النهارده. ده بيؤكد ثقة المجتمع الدولي في الأكاديمية أيضا. فكل الشكر وكل تقدير لكل حضراتكم من كل دولكم. والله نفسي أتمنى أذكركم كلكم بالاسم لكن هيبقى صعب عليا، يعني وهاخد دلوقتي كتير. فإن شاء الله ندي فرصة للزملاء يقدموا لنا يعني مختصر كده للرحلة بالأرقام غير بقى الرحله، الفيلم الصغير اللي احنا شفناه ده اللي بيجسد رحله على مدار سنه. الحمد لله رب العالمين. بتمنى لكم كل التوفيق، اشوفكم دايما على كل خير. شكرا جزيلا والسلام عليكم ورحمه الله وبركاته. بطلوا تفاجئوني تاني بالكلمات.
والآن يتفضل الأستاذ الدكتور أكرم سليمان السلمي، عميد كلية الهندسة والتكنولوجيا ورئيس اللجنة المنظمة للمؤتمر، لعرض ملخص يوضح أهم فعاليات وإحصائيات المؤتمر والمعرض المصاحب له، وكذلك الأحداث التي أقيمت على هامش المؤتمر. فليتفضل.
بسم الله الرحمن الرحيم. الحقيقة يعني فعلا الرحلة امتدت لأكثر من سنة. في الحقيقة أنا سعيد يعني الحمد لله إن إحنا وصلنا لآخر جلسة في مؤتمر مارلوج. الحقيقة 3 أيام، الحد والاثنين والثلاث دول بيعدوا كأنهم بالظبط يعني نص ساعة، بيعدوا بسرعة جدا، أحداث كثيرة جدا جدا. نتمنى ان احنا نكون يعني قدمنا حاجه فخورين بيها. الحقيقه يمكن قبل ما ابتدي البرزنتيشن حابب بس الحقيقه يعني لازم اقول الحقيقه كلمه مهمه جدا. احنا بنحاول دايما هو الواحد ان هو يعمل حاجه ناجحه، دي حاجه كويسه وحاجه يعني كلنا بنتمناها، بس الحقيقه دايما بيبقى الاصعب ان احنا نحافظ على مستوى النجاح ده وان هو يزيد ويتحسن من سنه لسنه. هي الحقيقه عمليه مش تاسك سهل ان احنا نكيبت وان احنا نديفلوب. في الحقيقه يمكن ودي حقيقه يعني ربنا سبحانه وتعالى يشهد عليها، احنا دايما الحقيقه نكون محتاجين افكار جديده نشتغل عليها. يمكن دكتور اسماعيل عبد الغفار اسماعيل فرج رئيس الاكاديميه العربيه للعلوم والتكنولوجيا والنقل البحري رئيس المؤتمر، الحقيقه يعني دايما ما شاء الله كده ربنا يعني دايما يخلي عنده هذه الملكه الجميله، وهي الحقيقه منبع افكار. والله وهذا كلام يعني هو كلام من القلب وكلام مخلص ليس فيه اي رياء، بس فعلا افكار كتيره جدا، يعني ممكن اقعد اقول حاجات كتيره جدا دكتور اسماعيل يعني بيقولها لنا واحنا يعني بنشتغل عليها بنحاول نحققها. يعني اعتقد حضراتكم النهارده في مارلوج 13 كان عندنا حلم من زمان قوي حققناه الحقيقه، يعني بفضل توجيهات الدكتور اسماعيل واحنا اشتغلنا عليه. احنا اصبح عندنا ابلكيشن على الاب ستور وعلى اللاند اندرويد، نازل عليه كل تفاصيل المؤتمر لاول مره. كل من هو سجل في المؤتمر، عشان كده الحقيقه السنه دي كنا حريصين ان يبقى كل الحضور بيقوموا بالتسجيل من خلال السيستم التسجيل اللي عملته الحقيقه طبعا كيانات الاكاديميه المختلفه واشتغلنا عليه وانتجنا هذا الابلكيشن، واصبح يعني زي اي مؤتمر عالمي، واصبح هذا الابلكيشن لكل الاحداث ان شاء الله اللي هتعملها الاكاديميه وليس المرلوج فقط. يمكن يعني موضوع المؤتمر ان شاء الله الدكتور اسماعيل يعني يساعدنا باعلانه. يعني الدكتور اسماعيل دايما الحقيقه بيدينا كل افكار، في الحقيقه يعني بشكره شكرا جزيلا دكتور اسماعيل. يعني فعلا ندعو حضرتك دايما بالصحه والسعاده والعافيه، وانت تستمر يا دكتور اسماعيل منبع كده افكار واحنا ربنا يقدرنا وننفذها ان شاء الله باذن الله. الحقيقه قطاع النقل البحري قطاع متجدد. يعني وجهة نظرنا المتواضعة ان هو بيشمل يعني كل العلوم وليس فقط العلوم البحرية، ولكن هي اقتصاد، هو تقدم، هو دولة، وبالتالي بيشمل العلوم البحرية والعلوم الهندسية والعلوم الاقتصادية واللوجستية والإدارية، الحقيقة كل العلوم. ويمكن من هنا جت يعني اختيار اسم المؤتمر النقل البحري واللوجستيات، وبنحط الحقيقة تحتيه موضوعات بتكون متوافقة مع الأحداث اللي يعني بتتم على مدار العام. فاسمحوا لي لو أعرض بسرعة المواضيع اللي تطرق لها المؤتمر هذا العام. اتفضل يا مروه. يمكن احنا اخترنا الثيم الاولاني Sustainable Resilience Infrastructure Perspective in Ports and Logistics for Climate Adaptation. يعني كل كلمة من دول يمكن يندرج تحتيها موضوعات هامة جدا. Emerging Technologies and Strategies in Maritime Industry, the Gateway of Optimization and Sustainability. Green Blue Infrastructure and Energy Transition and its impact on Port City. Sustainable end-to-end supply chain infrastructure aspect. Sustainable maritime law and regulation. Human resources competitiveness in maritime industry. Working towards a green blue investment framework. Ecosystem-based approaches for sustainable green blue maritime infrastructure and engineering. Smart, green, blue infrastructure, case studies and best practice. على الحقيقه يعني يمكن دي العناوين العامه. الحقيقه يمكن السنه دي لاول مره برضو يتم يعني اداره الجلسات بشكل متوازي. الحقيقه كنا سعداء يعني بالمشاركه الجميله اللي كانت موجوده على مدار المؤتمر، سواء على المستوى يعني السياسي او مستوى العلمي او مستوى الصناعه. عندنا الحقيقه احصائيات يعني نحب نقولها لكم كده، لان الارقام دايما بتعكس جوده ومستوى المؤتمر. احنا اول مره يمكن نوصل لهذا العدد 50 طبعا بعد ما الاستاذ الدكتور اسماعيل عبد الغفار اسماعيل فرج اشار الحمد لله ان المؤتمر اصبح موجود في سكوبا داتابيز. فاحنا الحقيقه وصلنا ل 54 فول بيبر سبمشنز. توتال برزنتيشنز خلال ال 13 جلسه للمؤتمر، احنا كان عندنا 13 جلسه كانوا 58 برزنتيشنز، منهم 16 كي نوت سبيكرز. الحقيقه كان في تنوع، كنا حريصين يبقى في من الصناعه وفي من الاكاديميا ويبقى في يعني من خبرات من معظم دول العالم زي ما هنشوف دلوقتي. وكان عندنا 42 بيبر برزنترز. الحقيقه كل الاوراق البحثيه تم تحكيمها بشكل حيادي تام بلايند ريفري من خلال سيستم الايزي تشير، ومن خلال طبعا بشكر الحقيقه فعلا ولازم هنا اشكر كل اللجنه العلميه، كل الزملاء من كل الكيانات داخل الأكاديمية العربية والجامعات المختلفة اللي ساعدونا في التحكيم. يمكن كان عندنا مشاركة من معظم دول العالم من ال5 قارات. عندنا مشاركة من 23 دولة، اليمن، تونس، السويد، إيطاليا، المغرب، فرنسا، اليونان، بلجيكا، السودان، المملكة العربية السعودية، بولندا، موريتانيا، الهند، أسبانيا، الصين، العراق، قطر، تركيا، جيبوتي، سنغافور، ليبيا، الولايات المتحدة، مصر، هونج كونج. لا كان عندنا مشاركة كبيرة جدا من الدول. يمكن يعني خدنا وقت كبير في حصرها لغاية آخر لحظة بنحصرها. لا أرجع ثانية واحدة بعد إذنك يا مروة. وكان عندنا حوالي 700 مشارك من تلك الدول. المشاركة سواء كانت حضور أو أوراق بحثية أو مشاركة في المعرض. فالحقيقة تنوع كبير جدا بيعكس الحقيقة الأرض اللي بيكسبها المؤتمر يوم بعد يوم. المعرض الحقيقة يعني وطبعا احنا يعني لاخر لحظه قد يكون نسينا بعض الكويت طبعا. معلش اعذرونا اذا كنا يعني لان فعلا احنا بنبقى بنحاول نقدم في الجلسه الختاميه لكن طبعا دي يعني بتناقح وبتراجع بعد كده ان شاء الله. فاعذرونا اذا كنا نسينا احدى الدول اللي زي ما قلت ده المشاركه سواء المشاركه كحضور او مشاركه في الاوراق البحثيه او في المعرض. هنا المعرض السنه دي الحمد لله كان معرض متميز، كان مشاركه كبيره جدا دوليه ومصريه وعربيه. الحقيقه برضو مرلوج الحقيقه انتقل من مجرد مؤتمر الى ملتقى، واحنا بنقول يعني هو فعلا ملتقى كبير. جهات كتيره جدا بتبقى حريصه انها تمارس سايد ايفنت على جانب مرلوج. كان عندنا السنه دي 3 احداث رئيسيه. طبعا ميد بوردز اسوسيشن حريصه على التواجد معانا، كانوا متواجدين في كسبيكرز متواجدين في المعرض، وايضا كان في تكنيكال كوميتي ميتنج على هامش المؤتمر. لاول مره الحقيقه الجلوبال شيبنج ثينك تانك الاينس GSTTA الحقيقه بنشكرهم على اقامه الاجتماع السنوي لاول مره منذ كورونا يتعمل فيزيكال، اتعمل هنا في مرلوج على هامش مرلوج. يعني كان في حضور في الاجتماع، وايضا شاركوا معانا في تقديم اوراق بحثيه. بشكرهم جميعا الحقيقه على وجودهم معانا. وطبعا الحقيقه كان في النهارده ورك شوب نظمها معهد تدريب الموانئ يعني بكوادر المتميزه مع جهتين يعني من اقوى الجهات على مستوى العالم في مجال الموانئ، الاتحاد العالمي للموانئ وميناء انتورب او معهد تدريب ميناء انتورب. والاول مره هذه الورك شوب تعقد يعني في المنطقه او في دول البحر المتوسط. اول مره يعني تطلع بره اوروبا، يمكن دي المره الثالثه على مستوى العالم. عقدت النهارده مشاركه متميزه. في الحقيقه بشكر جميع الزملاء على يعني على تنظيم الاحداث الجانبيه. الحقيقه يعني مصر واسكندريه واحنا الحقيقه طبعا بنفتخر الحمد لله ب يعني بالانجازات اللي موجوده على ارض الواقع. وعشان كده الحقيقه كان عندنا حرص برضو ان احنا يبقى عندنا سوشيال بروجرام. برضو حابين احنا نوضح ان كان عندنا زيارات جميله يعني تعكس الحقيقه التاريخ والعراقه اللي تميز بيها مصر واسكندريه. كان عندنا رحله قبل المؤتمر على طول يوم السبت لاسكندريه وللقاهره في نفس اليوم، واستمتعوا بعراقه وتاريخ مصر. كان ان شاء الله بكره اعتقد برضو عندنا رحله الى القاهره للاستمتاع بقى بال يعني المعالم الاثريه والحضاره الموجوده في القاهره. بشكركم شكرا جزيلا. نتمنى ان شاء الله ان احنا باذن الله يعني زي ما دكتور اسماعيل اشار احنا فعلا اسره المارلوج. يعني حقيقة قبل ما اختم كلمتي حابب بس اضيف حاجه صغيره قوي. الحمد لله الحاجه الاساسيه اللي احنا اتعلمناها الحقيقه وتعودنا عليها في الاكاديميه تحت رئاسه الاستاذ الدكتور اسماعيل عبد الغفار هو الحقيقه العمل الجماعي. يمكن انا النهارده حظي حلو ان انا يعني واقف بكلم حضراتكم، بس الحقيقه يمكن مش انا يعني الشخص اللي بالعكس، احنا الحمد لله فريق كامل جدا، يعني فريق كبير جدا جدا جدا. اعتقد يعني مش هقدر اقول، لكن هو فعلا فريق عمل متميز من كل كيانات الاكاديميه، الكليات، الجهات الداعمه، طبعا معهد الدير المواني ومركز البحوث. طبعا الحقيقه فريق عمل بيشتغل على مدار الساعه، على مدار اليوم، على مدار الاسبوع، على مدار السنه، عشان نقدر نطلع المنتج ده. بس بندي حقيقه مثل حلو جدا اللي هي كلمه النجاح احنا دايما بنشتغل بيها، وهو التيم ورك. شكرا جزيلا، وان شاء الله اشوفكم قريبا في مارلوج 14. شكرا جزيلا.
السيدات والسادة الحضور، إن الهدف المرجو من مؤتمر الدولي للنقل البحري واللوجستيات هو الخروج بتوصيات مؤثرة وفعالة، وذلك من أجل تقدم وتطوير النقل البحري والموانئ في مصر والمنطقة العربية والعالم. بالإضافة إلى أن مؤتمر هذا العام يتميز بنشر أوراقه البحثية في قاعدة البيانات سكوبس، وهي أكبر قاعدة بيانات على مستوى العالم. وبالتالي فقد قامت اللجنة العلمية لمؤتمر هذا العام باختيار أفضل الأوراق البحثية وفقاً لمعايير جودتها ومحتواها العلمي، وهو ما يتسق مع المستوى المميز للأوراق البحثية المقدمة والتي تم عرضها ومناقشتها من حيث التنوع والمحتوى العلمي. والآن يتفضل الأستاذ الدكتور علاء محمود مرسي عميد معهد تدريب الموانئ لعرض توصيات المؤتمر، وكذلك للإعلان عن أفضل 3 أوراق بحثية قدمت للمؤتمر، وأيضاً عرض بيانات الأوراق البحثية التي تم ترشيحها لمجلة International Business Logistics.
بسم الله الرحمن الرحيم. يمكن التوصيات اللي خرج بها المؤتمر السنة دي هي منبعثة من السادة رؤساء الجلسات، وبالتالي يعني بنشكر كل السادة رؤساء الجلسات اللي قدموا التوصيات لكل جلسة علمية من الجلسات. نبدأ بذكر التوصيات الخاصة بالمؤتمر. التوصية رقم 1: Implement green initiatives in port and logistics area to minimize environmental impact and promote clean energy solutions. Moreover, enhance regional cooperation in the Mediterranean for sustainable pro-economy, focusing on concrete projects with significant impact. Number 2, conduct research for infrastructure projects of new port and logistics area, considering sustainable development principles, taking into account future ship size in the infrastructure design, including pier design, depths, and logistics access. This is applied in a collaboration with the global shipping lines operators. Recommendation number 3, adopt modern technology such as automation, artificial intelligence, Internet of Things, and blockchain to enhance efficiency and safety in port logistics and information exchange through digital platforms to improve transparency and enhance the flow of goods. Recommendation number 4, activate port's role as an integrative logistics center that offer all services related to ships and the movement of goods while linking with global supply chain, integrating between port regionally and globally with the aim of reducing cost and increasing the quality of services provided. Recommendation number 5, focus on the investment opportunities in port and logistics area, prepare prior feasibility studies, as well as get the benefit from the experiences of global ports related to the flexibility of supply chain and their impact on the economic and global trade. Recommendation number 6, improve rail and maritime connection between ports and mode of transport such as railway, roadway, waterways, with the framework of multimodal transport to link between port and industrial and commercial center, aiming of increase efficiency of logistic services with competitive prices. Recommendation number 7, enhance integration between ports, shipping company, logistic services providers, and governments to improve global supply chains operators. Recommendation number 8, embrace a unified goal in a unified legal framework that align with modern global trend in port and logistics. Recommendation number 9, pay attention to training and qualifying workers in port and logistics area on how to deal with modern system using simulation systems in training to enhance skills in using modern technology. The last recommendation, work on reducing the handling time and storage time within port in a gradual timeline to achieve storage elimination within seaport in coordination with relevant entities such as a custom and export and import control. This is the 10 recommendation which has been submitted from this conference this year. في الحقيقة بناء على توصيات اللجنة العلمية للمؤتمر ومنتهى الحيادية والشفافية عن طريق أيضا استخدام السوفت وير اللي احنا كلنا بنعمل ابلودنج للبيبرز عليه اللي هو الايزي تشير. يعني احب ان انا اعلن اختيار افضل 3 جوائز لافضل 3 اوراق بحثيه في المؤتمر هذا العام. نبدا بالبيست بيبر اوورد رقم 3، دكتور انريكو Logistics Cooperation in the Far East. The name of the paper, Prioritizing Supply Chain Requirement to Strengthening Inter-Regional Integration of Maritime Transport Network. الورقة البحثية صاحبة المركز الثاني دكتور ميريلان كومبر Logistics Performance as Facilitator to Trade Performance and Indian Perspective. والآن الورقة البحثية صاحبة المركز الأول بروفيسور جين هون جين Data and Model Dual Driven Approach Optimizing Appointment Quota of External Container Truck. يعني أعتقد واضح جدا مدى الحيادية والشفافية في اختيار الأوراق البحثية. أيضا تم اختيار 10 أوراق بحثية من الأوراق البحثية التي قدمت في المؤتمر، وذلك للنشر في International Business and Logistics Journal. يعني هقول كده الأسماء سريعة. الأوراق اللي تم نشرها: Investigating the Impact of Maritime Trade New Trends, Improving the Quality Services in Logistics Company Using the Petro Analysis, Stability Analysis of Maritime Logistics Alliance based on blockchain, Data and Model-Driven Approach Optimizing Appointment Quota of External Container Truck, Logistics Performance as a Facilitator to Trade Performance in an Indian Perspective, NCOS Online and the Future of Port Operation Insights from the Digital Integration of the Port of Hamburg, Germany, Measuring Green Port Management as a Determinant of Port Attractiveness and Competitiveness, District Event Simulation of the Tracked Appointment System in Container Terminal, a Dual Transaction Approach, the role of applying advanced cargo information system on improving the performance of Alexandria Port, Simulation Optimization Model in Management the Empty Container Movement Problem through a repositioning strategies. دول ال10 أوراق البحثية اللي تم اختيارهم في International Business Logistics Journal. شكرا جزيلا لحضرتك.
السيدات والسادة الحضور، ندعو الآن سعادة الأستاذ الدكتور إسماعيل عبد الغفار إسماعيل فرج، رئيس المؤتمر ورئيس الأكاديمية، لتكريم السادة رؤساء الجلسات، فليتفضل. الأستاذ الدكتور حسام مغازي، وزير الموارد المائية والري الأسبق. السيد فرانسيسكو لافلر، رئيس اتحاد البنية التحتية للنقل المائي بيانك، بلجيكا. الأستاذ الدكتور خالد السقطي، عميد كلية النقل الدولي واللوجستيات بالقاهرة بالأكاديمية العربية، ويتسلمها عنه الأستاذ عمر خالد، مدرس مساعد بكلية النقل الدولي واللوجستيات فرع القاهرة. السيد بينو موسلينو، رئيس اتحاد موانئ البحر المتوسط ورئيس هيئة الموانئ روما. الأستاذ الدكتور عزيز عزت، مستشار رئيس الأكاديمية لشؤون التعليم. الدكتور السنوسي بلبع نائب رئيس الأكاديمية للشؤون البحرية. الأستاذ الدكتور محي الدين السايح عميد كلية النقل البحري والتكنولوجيا بالأكاديمية العربية للعلوم والتكنولوجيا والنقل البحري. بروفيسور ماكسيمو ماهيا رئيس الجامعة البحرية الدولية مالمو السويد. الوزير مفوض دكتور بهجة أبو النصر مدير إدارة النقل والسياحة بجامعة الدول العربية. سعادة الكابتن محمد حسن مختار مدير عام هيئة الموانئ البحرية السودانية. الأستاذ بدر العتيبي دولة الكويت.
وصلنا إلى الميناء بسلامة الله وانتهى مؤتمرنا هذا العام، ولكننا نعدكم بأن تبحر سفينة مارلوج مرة أخرى وموعدنا في العام القادم ونسخة جديدة من مؤتمرنا مارلوج 14. فليتفضل سعادة الأستاذ الدكتور إسماعيل عبد الغفار إسماعيل فرج رئيس المؤتمر ورئيس الأكاديمية ليعلن عن موضوع وموعد مارلوج 14.
تفضل بليز. بسم الله الرحمن الرحيم. على بركة الله تستمر سفينة النجاح تبحر بإذن الله تعالى لما فيه صالح إنسانية كلها، البشرية، أمتنا العربية، مصر أم الدنيا. تستمر مسيرة مارلوج، نتعلم، ننشر أبحاث علمية متميزة، ندي مثل وقدوة للأجيال، ندي نموذج للتفاني والإخلاص. ودايما أكيد لن يكون جزاء الإخلاص إلا النجاح بإذن الله تعالى. ربنا يحفظ الإنسانية كلها، يحفظ مصر، يحفظ أمتنا العربية، يحفظ أهلنا في كل مكان. ربنا يوفقكم كلكم. نلتقي إن شاء الله على بركة الله. نتمنى نكون جميعا سويا بكل الخير والبركة في رحاب الأكاديمية العربية للتجارة والنقل البحري في عام 2025 بإذن الله تعالى. لكن سامحونا المرة دي نلتقي في فبراير العام القادم، عشان خاطر يعني شهر رمضان المبارك بإذن الله تعالى اللي بيهل علينا خيره وبركاته في خلال أيام بسيطة. والسنة دي في مصر أم الدنيا وفي العالم يصوم كل أهل مصر مسلم ومسيحي مع بعض يوم الاثنين 11 مارس بإذن الله تعالى إن شاء الله. كل سنة وانتم طيبين. نلتقي على خير إن شاء الله العام القادم 23 25 فبراير 2025 في النسخة 24 من النسخة 14 من مارلوج بإذن الله. Let us hope to meet all together coming year 2025 from the 23rd to 25th of February 2025 on the Marlog 14th, the 14th edition of the International Maritime and Logistics Conference. And we have chosen the coming edition to be artificial intelligence implementations towards shaping the future of the digital world. I hope we're going to meet all together. كل الشكر وكل التقدير لحضراتكم مرة تانية. أتمنى ربنا يدينا العمر والصحة نكون مع بعض جميعا بكل خير وبركة إن شاء الله العام القادم 2025. أتمنى كلكم تكونوا موجودين معانا هنا إن شاء الله. نتمنى يعني كثير من الإخوة من العرب ومن كل الدنيا يكونوا موجودين معانا إن شاء الله. شكرا جامعة الدول العربية على الرعاية. شكرا معالي الأمين عام جامعة الدول العربية على الرعاية والدعم. شكرا وزارة النقل جمهورية مصر العربية. شكرا معالي الفريق كامل الوزير على الدعم وعلى الرعاية. شكرا مصر أم الدنيا. شكرا دولنا العربية. شكرا كل الزملاء من كل دول العالم اللي شاركوا معانا. شكرا اللجنة المنظمة. شكرا أبنائي طلبة الأكاديمية. شكرا زمايلي أسرة الأكاديمية. شكرا كل من أسهم. حقيقي جنود كتير يعني لن يتسع المقام لذكرهم، لكن على بركة الله نعلن نهاية وختام هذه المرحلة، وصول إلى نهاية محطة مارلوج 13. وعلى بركة الله ننتظر إن شاء الله وندعو ربنا نلتقي سويا في مارلوج 14 بإذن الله تعالى 23rd to 25th February 2025 بإذن الله تعالى. شكرا جزيلا والسلام عليكم ورحمة الله وبركاته.
السيدات والسادة الحضور، ندعو حضراتكم جميعا لالتقاط صورة تذكارية للمؤتمر الدولي للنقل البحري واللوجستيات مارلوج 13 مع سعادة الأستاذ الدكتور إسماعيل عبد الغفار إسماعيل فرج رئيس المؤتمر ورئيس الأكاديمية. ندعو الآن اللجنة المنظمة لالتقاط صورة تذكارية.